හරි ළමයි එහෙනම් good evening හැමෝටම හරි ළමයිනේ අද ලොකු වැඩක් කරන්න හදන්නේ හරි හරි ලොකු වැඩකට යන්න හදන්නේ හරි මගේ ටාගට් එක අද දවස ඉවර වෙනකොට ඒ කියන්නේ something close to 6 hours වගේ තියෙනවා අපි උපරිම බලමු හරි totally අපේ වැඩේ ඉවර කරන්න හරි මට පොඩි වෙලාවක් දෙන්න ළමයි වැඩේ පටන් ගන්න කලින් මම හිතනවා හැමෝම ගාව ඇති English medium tutorial එක මම provide කරපො හරි ඒකේ print out එකක් අරගෙන තියෙනවා නම් හොඳයි හරි ළමයි inorganic chemistry කියවහම මේක ඇත්තටම මේ හරි lazy එකක් එහෙම අමාරු එකක් නෙමෙයි when you come to inorganic chemistry guys there are roughly 10 MCQs hurry roughly 10 MCQs are there under SPD block chemistry under the unit 10 MCQs are there another 4-5 MCQs are there for industrial chemistry as well so 10 MCQs is there and question number 2 second structure essay in A-level chemistry paper that is completely inorganic chemistry question. So out of final 100, there are another 5 marks for that one. Hurry, another 5 marks for that one. Hurry. And when we come to part B, essay number 7, section B also containing inorganic question. Hurry. Actually, in that question, only part B, 2 marks for that question. The total is out of 100, that is 7.35 marks. Okay, 7.35 marks. And also, essay number 9, section A also contain another 3.75 marks for the inorganic. Essay number 9, section B, that is also a redox titration question. Actually, you need a well-known inorganic knowledge for that one. Hari, ekak 3.75 වෙනවා. හැබැයි මම ඒක neglect කරගෙන ඉන්නම්. Hari. If you only consider these things, roughly here 7.5, here 5, 12.5, another 10 MCQs are there. So totally 22.5 marks of inorganic chemistry. Hari. So when you go to inorganic chemistry questions, guys, according to theory, there are S block chemistry, P block chemistry, and D block chemistry. But when you come to these questions, Hari, questions are little bit different. You need to know properly about Hari, analytical chemistry because there are something close to 14 practicals in this unit. Those questions are usually asked from these practicals. So we need to know about identification of cations and ions as well as there is another very important thing that is called group analysis. Hari, එනම් අපිට ලොකු වෙලාවක් නැහැ. Something close to 6 hours විතර වගේ තියෙන්නේ. Around 12 මම ඉන්ටර්වල් එකක් දෙන්නම්. අපි වැඩේ පටන් ගමු. Okay. හරි. ළමයි ගන්න ටියුට් එක හරි. ටියුට් එක ගන්න. Under the analytical chemistry ළමයි හරි. The first section I'm going to discuss is cation analysis. Cation analysis that is known as group analysis. Hari. ළමයිනේ actually group analysis that is a qualitative analytical method. Hurry. In this method, we are identifying different metal cations under different groups. Usually, if there is a cation mixture, using 6 groups, we can identify these things. In theory, under the SPD block element chemistry, order make a humble in it. හැබැයි essay questions බලන්න ගියාම හරි ඔයාලා මේක නැතුව කිසිම essay question එකක් ලියන්න වෙන්නේ නැහැ. So very important thing here හරි cation analysis, group analysis. හරි look at this one. Here primarily an initial mixture of cation is taken and a certain compound is applied externally to the initial cation mixture to precipitate the cations present in the initial cation solution. In this process, precipitate settle at the bottom of the solution and there is a solution above the precipitate. This solution is referred to as the filtrate or supernatant solution. Guys, majority of people, they don't know about the supernatant solution. At the bottom there is a precipitate. The above solution, that is known as supernatant solution. Okay. එහෙනම් අපි ලියාගෙන එමු group analysis එක ගැන. There are plenty of space. Guys, look at this one. There are 6 groups. When we come to the first group, when we come to the first group, guys, we are adding cold dilute HCl to the mixture of cation. Actually, we can obtain 3 types of precipitates, guys. Look at this one. If Ag plus is present, okay, it will give silver chloride, AgCl. If Pb2 plus present in this cation mixture, it is also given as a white precipitate, PbCl2 solid. Hg22 plus mercurous ions also there. If mercurous ions available, Hg2Cl2 precipitate is given. So all these precipitates are white color precipitates. They are white in color. So when you add in dilute HCl to a mixture of cation, if you observe a white color precipitate, it can be AgCl, it can be PbCl2, or it can be Hg2Cl2. Maybe sometimes it contain all these 3 cations. අපිට identify කරන්න වෙනවා. අපි එහෙනම් note එකට set වෙමු. ළමයි ලියන්න. හරි, group 1. Under the group 1, write down. හරි. You having spaces. Our topic is group analysis. හරි. Topic is group analysis. Then මම අද දවසේ මේ theory ටික තමයි apply කරවන්නේ. කොහොමද theory ටික base වෙන්නේ කියන එක. ඊට පස්සේ මම මේ මාසෙ පුරාවටම ඔයගොල්ලොත් එක්ක inorganic chemistry වල pass paper essay කරන විදිය කියලා දෙනවා. So ඔයාලට තේරෙයි මේ questions කොච්චර එදෙනවද කියලා. හරි, මේ theory එක කොච්චර එදෙනවද කියන එක. එහෙනම් ලියමු ළමයි මුලින්ම. Let's write down. Add cold diluted HCl, add cold diluted HCl to the mixture of cations. A white precipitate can be obtained. If Ag plus Aq, Pb2 plus Aq, and Hg22 plus Aq present in the mixture. A white precipitate obtained if Ag plus Aq, Pb2 plus Aq, Hg22 plus Aq present in the mixture. So write down this equation. When you add in cold dilute HCl to a mixture of cation, if these cations are present, you can obtain a white color precipitate. Quickly write down. Guys, here we are using dilute HCl. There is a reason. I'll give you the reason after this point. Can you quickly write down this one? Okay. Lamai, if we use concentrated HCl here, HCl, both AgCl and PbCl2 With the further addition of concentrated HCl, they dissolve. When AgCl react with conc-HCl, the concentrated HCl, it converts to AgCl2 minus, which is a complex. I think now majority of you guys go through the D block chemistry. If there are square brackets like that, it represents a complex. So not only AgCl, but PbCl2, that is also go to a complex and form PbCl4 2 minus. As a point form, write down after these three equations. Lianna මෙහෙම ළමයිනේ. Both PbCl2 and AgCl, silver chloride, both PbCl2 and silver chloride dissolve in the presence of concentrated HCl. Could you write down these two equations? Harry? So the thing happened here is, assume aqueous solution is given to you. We are adding dilute HCl to that aqueous solution. If you obtain a white precipitate, you can identify that white precipitate can be AgCl, PbCl2 or Hg2Cl2. Which means these cations can be present. If you want to further identify these things, actually you can separate precipitates. You can separate these precipitate and you can add concentrated HCl. When you add in concentrated HCl, only Hg2Cl2, that does not dissolve. But the other two, AgCl and PbCl2, those precipitates are dissolved in the presence of excess HCl. Both these two are dissolved in the presence of excess HCl, no concentrated. There's another method to separate these things also. I'll go through those things later. This is the group 1. So what in group 1? We add in cold dilute HCl to a mixture of cation. If we can obtain a white color precipitate, and we can identify that the presence of these three cations. Sometimes method okay. Now let's go to group 2. Second group. Go to group. Let's go to group 2. Group 2. This one. I'm going to remove this one here. Let's go to group 2. Okay. Now, when we add in dilute HCl to a mixture of cation, if we can obtain the precipitate, we can identify these three cations are present. We have to take this solution. I gave a name for this solution that is known as supernatant solution. Okay. That is known as supernatant, or we can consider that one as filtrate as well. Then, in the second case, guys, in group 2, we have to filter this precipitate. And we can take this supernatant. And we are passing H2S through that one. Api ලියලා එමුකෝ එක. ලියලා ඉන්න ළමයි. හරි. ලියමු ළමයි මෙම. හරි. Obtain the filter rate, or otherwise you can write down the supernatant. Obtain the filter rate by filtering the precipitate filtering the precipitate by filtering the precipitate from group 1 from group 1 from group 1 guys මට පොඩි වෙලාවක් දෙන්න මේ සමහර අය links ගිහිල්ලා නැති පොඩි ගැටලුවක් තියෙනවා හරි ඒක බලලා ඕකේ කරයි හරි obtain from group 1 හරි and bubble H2S through it and bubble H2S through it. Okay, when we come to group 2 we have to take the filtrate or the supernatant. Okay, and we have to pass H2S through it. Within bracket write down acidic medium. Hurry, acidic medium. The reason guys, now the medium is acidic. Why? What is the reason? In the previous case, we pass HCl. We add dilute HCl to the mixture. When we add in dilute HCl mean definitely the medium is acidic. Actually there is a physical chemistry background behind this one under Lechatlier principle. Mama දැනට ඒක explain කරන්න නැතුව ඉන්නම්. Space එක තියලා තියෙන එකට ඒක පස්සේ දවසක ලියාගමු. හරි. Under the acidic medium. තමයි ලියන්න. හරි. Can obtain 9 precipitates. In the group 1, 3 precipitates. But when you go to group 2, you can obtain 9 precipitates. You can obtain 9 precipitates. 9 precipitates. When you come to those 9 precipitates, guys, actually 4 black precipitates are available. 4 black precipitates. 3 yellow precipitates also there. And 1 orange precipitate and as well as 1 brown precipitate is there. Hurry. 1 brown precipitate also there. Give me a second. Hurry. If Hg2 plus, in the previous case guys we write down that one as Hg22 plus, mercurous. But this one it is mercuric. Okay, 2 different things. Pb2 plus, another very important thing, when we come to Pb2 plus, it is precipitate in both group 1 and 2. Hg2 plus, Pb2 plus. And there are another 2 cations, copper 2 plus and bismuth 3 plus. Copper 2 plus Aq and bismuth 3 plus Aq. They gives black precipitate with the presence of H2S. Actually, we can obtain sulfide precipitates. Mercuric sulfide, it is a black precipitate. Lead sulfide, that is also a black precipitate. Copper sulfide, that is also a black precipitate. Bi2S3, that is also a black precipitate. So I'm going to remove this thing. Actually guys, no need to balance. They never ask you to balance these things and okay, those write down those equations. We just need the cations only. Those are the 4 black precipitates. Except for those 4 black precipitates guys, there are 3 yellow precipitates. Those things are cadmium 2 plus. If cadmium 2 plus is there, it gives a yellow precipitate. Arsenic 3 plus. Arsenic 3 plus. All these aqueous things. If these aqueous ions are present, then SN4 plus. They go to their sulfides precipitates. Those things are yellow in color. SnS2. All these precipitates are yellow in color. And there is an orange color precipitate. There is Sb3 plus. If Sb3 plus Aq is there, in the presence of H2S, it convert to Sb2S3 lamine. Sb2S3. It is a orange color precipitate. Finally, there is a brown color precipitate, that is SN2 plus AQ. If SN2 plus AQ is there in the presence of H2S under acidic medium, it goes to SNH solid, which is a brown color precipitate. All these things are precipitate, okay? So when we add in, when we pass in H2S through the filter rate obtained from the group 1, you can obtain 9 precipitate. Out of those 9 precipitates, there are 4 black precipitates, 3 yellow precipitates, and 1 orange precipitate and 1 brown precipitate. Okay, could you write down these things? You have to remember these things. Hurry. You have to remember these things. You have to memorize these things. Hurry. That is really easy. Hurry. Now we know. Let's go to the big start. Hari api mulai indala yamu. Api mulin kata kare, we have to add dilute. Hari, we have to add dilute cold HCl to a mixture of cation. If actually white precipitate is present, those can be Pb2 plus, Hg22 plus, and Ag plus. Then we have to filter the precipitate and we have to take the filter rate. We have to pass H2S through this solution. Now the medium is acidic. We can obtain 9 precipitate. If you obtain a orange color precipitate here, definitely you can consider the cation is Sb3 plus. If you obtain a brown color precipitate only, you can definitely consider Sn2 plus. But if you observe a yellow color precipitate, we cannot exactly say what is that one out of these 3. It can be cadmium 2 plus, arsenic 3 plus, or SN4 plus. The same thing with the black color precipitate. Using further experiments, we can directly identify the cations. Very important group analysis. මම මේකට ලකුණක් දුන්නොත් මම ඔයාලා ලියන අතරේ මම කතා කරන්නේ. හරි. මේක දන්න අය දන්නවා. හරි. මේකට ලකුණක් දුන්නොත් මේ group analysis කියන ටිකට group 6 තියෙනවා. මේකට මට A level paper එකෙන් total value එකෙන් 100ට 3ත් 4ත් අතර වගේ value එකක් දෙන්න පුළුවන්. මේ චූටි section එකට group analysis out of final 100. For the atomic structure, out of 100 there are 2 marks. First unit take a validity at 2 marks, but this section something close to 3 to 4 marks. So really important. Really important. Okay. Quickly write down these things. Quickly write down. There are 9 precipitates. Okay. 9 precipitates can be obtained. The make a lesson to මතක තියාගන්න ඕනේ. හරි. හොඳට මතක තියාගන්න ඕනේ. වැඩේ කොට දාන්න. Okay, Lamai. Now let's go to group 3. Actually, when we come to group 3, there is a procedure for the group 3. There is, as in the previous group, initially we have to filter the precipitate. Then we have to take the filter rate, and to the filter rate we are adding HNO3. The purpose for adding concentrated HNO3 is to convert Fe2 plus ions to Fe3 plus. Is to convert Fe2 plus ions to Fe3 plus. After that, we are adding ammonium hydroxide and ammonium chloride. Okay. So, මම හිතනවා දැන් මේක ලියලා ඉවර ඇති. හරි. අපි යමු group 3 එකට. Let's go to group 3. හරි. Let's go to group 3. Hurry. Guys, write down. Obtain the filter rate by obtain the filter rate by obtain the filter rate by filtering the precipitates from the precipitates from group 2 at concentrated HNO3 to convert Fe2 plus to Fe3 plus to convert Fe2 plus to Fe3 plus. Then add I'm going to remove this section. Then add ammonium chloride and ammonium chloride and ammonium hydroxide. Then add ammonium chloride and ammonium hydroxide. Guys, let's write down. 3 precipitates can be obtained. 3 precipitates can be obtained. 3 precipitates. Only 3 precipitates can be obtained. Okay, lamai mathaka tiyaganna. You can obtain a green blue precipitate if Cr3 plus ions are present. If Cr3 plus ions are present, you can obtain chromium hydroxide, CrOH thrice. And you can obtain a white color precipitate, if Al3 plus ions are present. And you can obtain a reddish brown precipitate, if Fe3 plus ions are present. Okay. Can obtain 3 precipitates. Write down these 3 precipitate. If chromium 3 plus present in the presence of ammonium hydroxide and ammonium chloride, after treating with concentrated HCl, it converts to CrOH thrice. If aluminium 3 plus is there, it gives white precipitate, which is aluminium hydroxide. If ferric is there, it gives reddish brown precipitate, which is ferric hydroxide. Okay. Quickly write down. මම ලියන අතරතුර මම කියන ඕගොල්ලන්ට question එකක් ලියන්න එපා. මේක ලියන අතරතුර නිකන් අහගෙන ඉඳලා මට කවුද කැටයන්නේ කියලා identify කරන්න. හරි. Initially we are in cold dilute HCl to a mixture of cation. No precipitate obtained. Then we are passing H2S through the cation mixture. Again, no precipitate obtained. After that, we are adding concentrated nitric and add ammonium chloride and ammonium hydroxide. If a green color precipitate obtained, and here question a green color precipitate obtained. How do we the green color precipitate? That is chromium hydroxide. Are you okay with that one? Same question same chemicals add karanawa. After that, I'll give that a reddish brown precipitate is obtained. Look at this one. we are initially adding dilute HCl, then no precipitate, then passing H2S to the solution, again no precipitate, then we add in concentrated HCl, sorry, HNO3, concentrated nitric. After that we add in ammonium chloride and ammonium hydroxide, you can obtain a reddish brown precipitate. What is the cation? What is the cation? සමහර විට කියන්නේ නැත්තේ Fe3+. No. There are two choices. We don't know. Maybe the initial mixture contained Fe3+. So no issue at all. That is okay. If the initial mixture contained Fe2+, the same result can be given. The reason, if Fe2+ in the initial mixture with the addition of concentrated HCl, 2+ convert to 3+, then also it gives a positive feedback for this reaction. So එකෙන් අපිට කියන්න බෑ confirmly 100% 2+ the 3+ the කියලා. Like that. හරි. අපි බලමු මොකක්ද වෙන්නේ කියලා. හරි. ළමයි ඊළඟට හරි. ඊළඟට I'm going to remove this one. Make a leave other. Hurry, quickly liagan. Quickly liagan. Hurry. Ikban liagan. Lamai, then group 4. Again the same thing. Again the same thing. We have to pass. We have to filter the solution. We have to remove the precipitate. We have to take the filtrate. After that, we have to pass again H2S through the solution. We have to bubble H2S through the solution. Actually, we also undergo through the same procedure in group 2 as well. Here also the same procedure, but guys, here we already add ammonium hydroxide. So now the medium is basic. Do you remember? In the first case, the medium is acidic. Now it is basic. Here we can obtain 4 precipitates. We can obtain 4 precipitates. Out of those 4 precipitates, there are 2 black precipitates. 2 black precipitates. Guys, if cobalt 2+ or nickel 2+ is there, they precipitate as their sulfide. Cobalt sulfide, nickel sulfide. Hurry. Okay. If manganese 2+ is there, it gives a pink color precipitate. If zinc 2+ is there, it gives a white precipitate. It gives a white precipitate. Other one lower class came question nek kara zinc sulfide white precipitate dena katandaraya. මතකයට ඒක okay ඇති. හරි. අපි ලියමු group 4. Let's write down the procedure initially. Let's write down the procedure. ලියන ළමයිනේ. හරි. Filter the precipitates and filter the precipitate and the කොමාරි අද දවස මේ ටික අල්ලන් ඉන්න A-level exam එකෙන් ඔයාට ලකුණු 20ක් closely 20 marks ලියන්න පුළුවන් වෙන එකට අදාළ theory හම්බෙනවා. හරි. ඒක මේක theory class එකේ inorganic නෙමෙයි. ඒක SPD කියලා කරන inorganic එක නෙමෙයි මේ. ඒකෙන් ඔයාලා ලකුණු ගන්න බෑ. ඒකෙන් roughly out of that 23 marks තමයි. හරි. තමයි ලියන්නේ මෙහෙම. හරි. Obtain the filter the precipitate and obtain the filtrate from group 3. Bubble H2S through it. Bubble H2S through it. Within bracket write down, guys. The medium is basic. The medium is basic. ඊළඟට ලියන්න ළමයි. ඊළඟට ලියන්න 4 precipitates can be obtained. Here 4 precipitates can be obtained. These are the precipitates: 2 black, 1 pink, and 1 white precipitate. Actually pink කියන්නේ ටිකක් pale pink ගතියක් තියෙනවා. Okay. දැන් ටර්ම් ටෙස්ට් තියන අයට ඩෙෆිනිට්ලි මේවා අහනවා. හරි. හරියට questions ටික කරලා යන්න past paper essay questions ටික. හරි. group 4. Cobalt and nickel give black precipitates. Manganese a pink color precipitate. Zinc a white color precipitate. Okay. Now let's go to group 5. Let's go to group 5. Group 5. Sorry. Now again we have to same the thing. We have to filter the precipitates and take the filter rate. Sorry. Abiliyam here group 5 gana. Let's write like this. Obtain the filter rate. Obtain the filter rate. Obtain the filter rate by filtering the precipitate. By filtering the precipitate. By filtering the precipitate. By filtering the precipitate from group 4. From group 4. Hurry. Boil for few minutes. Boil for few minutes. Boil for a few minutes to remove H2S. Boil for a few minutes to remove H2S. You have to boil the solution. Then add a small amount of ammonium chloride. Add a small amount of ammonium chloride. Then followed by ammonium hydroxide and ammonium carbonate. And ammonium carbonate. And ammonium carbonate. Okay. Now look at this one. Here, now you obtain 3 types of precipitates. You can obtain 3 types of precipitates. If calcium 2 plus, barium 2 plus, and strontium 2 plus is present, in the presence of these reagents, they convert to their relevant carbonates. Calcium carbonate, strontium carbonate, and barium carbonate. Okay. These things are white color precipitate. White precipitate. අපි එවලියමු ලියන්න එහෙනම් 3 white precipitates can be obtained. 3 white precipitates can be obtained. 3 white precipitate can be obtained. Let's write down those 3 white precipitates, Lamal. Sorry. Let's write down those 3 white precipitates. Calcium, strontium, and barium. They give white precipitates. හරි. මම මේ පාස් පේපර් ක්වෙස්චන් එකකුත් නිකමට ගත්තා. හරි. මම ඔයාලට කියන්නම් කොහොමද ඒකේ ෆ්ලෝ එක තියෙන්නේ කියන එක. ඒක රැන්ඩම් ක්වෙස්චන් එකක් අපි සිලෙක්ට් කරන්නේ. टोटल बෑ තව එක group එකක් තියෙනවා අපි ඒකෙනුත් ගිහිල්ලා වැඩේට යන්. හරි. ළමයි let's go to the last group, the group X. හරි. Here also we have to do the same thing. We have to main over පට්ටලේසිය ලකුණු CNC ගන්න පුළුවන්. හරියට වැඩේ හිටියෝ. හරි. Let's go to group 6. To the group 6, we are doing the same thing, guys. We have to take the precipitate by filtering, and we have to remove the remove the precipitate and take the filtrate, and we are adding a chemical called 8-hydroxyquinoline. Okay, අපි ලියලා මෙහෙම ලියලා ළමයි නේ. හරි. Obtain the filtrate by filtering the precipitate from group 5 and add 8-hydroxyquinoline 8-hydroxyquinoline here QUI quinoline to the solution. If Mg2 plus ions are present, a yellow color complex is obtained. Hurry. Lamai, out of 100, this is roughly around 3 to 4 marks. 3 to 4 marks. This is the group analysis. Order make up superior mataka තියෙන්න ඕනේ. හරි භාගයට අඬා කියලා බෑ. කොහොමද? Adding cold dilute HCl to a mixture of cation Ag plus Pb2 plus Hg2 plus precipitate as white color precipitate. Then filter and take the supernatant, and we have to pass H2S through that one. 9 precipitate can be obtained. Out of those 9 precipitates, there are 4 black precipitate. What are those black precipitates? Pb2 plus, Hg2 plus, Bi3 plus, and copper 2 plus obtained as black color sulfide precipitate. There are 3 yellow precipitate. What are those 3 yellow precipitate? Sn4 plus, As3 plus, arsenic 3 plus. Are you okay with that one? Then there is a orange color precipitate. What is the orange color precipitate? That is Sb3 plus. It precipitated as Sb2S3. There is a brown precipitate as well. That is Sn2 plus. S is the precipitate. Then we have to remove the precipitate and take the filtrate. We have to add concentrated HNO3. Why we are adding concentrated HNO3? To convert Fe2 plus to Fe3 plus. After that, you have to add ammonium chloride and ammonium hydroxide. 3 precipitates can be obtained. Chromium hydroxide, which is a green color precipitate, aluminum hydroxide, a white color precipitate. If Fe3 plus is there, that is a reddish brown precipitate. Actually, if you obtain a reddish brown precipitate, you cannot exactly say Fe3 plus in the initial mixture. It can be Fe2 plus or Fe3 plus. You know about that one. Then what you have to do? Then you have to remove the filter. remove the precipitate and take the filtrate, and you have to pass H2S through that solution. That is now under a basic medium. There are 4 precipitates: cobalt nickel, black precipitate; zinc, white precipitate; manganese, pink color precipitate. After that, you have to go to the group 4. When you come to group 4, you have to add small amount of ammonium chloride followed by ammonium hydroxide and ammonium carbonate. 3 precipitates can be obtained. Those things are calcium, strontium, barium. After that, you have to add 8 hydroxyquinoline under the group 6. If you can obtain a yellow color complex, that will confirm the presence of Mg2+. Are you okay with that? You have to remember well. Hari. Now I am going to choose a random question in past papers. Hari. මම මේකේ answer එක කියන්න යන්නේ. හරි. question ගොඩක් මෙහෙම තියෙන ළමයි. questions ගොඩක් මේ විදිහට තමයි තියෙන්නේ. මෙන්න question එක මෙහෙම දීලා තියෙනවා. ඔයාලගේ paper එක නැති වුණාට කමන්නේ. හරි. මම completely කතා කරන්නේ. හරි. මේකේ තියෙනවා maybe ඔයාලට click වෙයි සමහර ඒවා. 75 marks තියෙන්නේ මේකට. හරි. This is the question. Solution P contain 2 cations and 2 anions. We only have knowledge to identify the cation yet. Look at this one. A dilute HCl is added through the mixture of cation and followed by H2S. A clear solution is obtained. So, no any cations under group 1, no any cations under group 2. Group 1, group 2 metal cations are absent here. That's why we obtain a clear solution. Then what happened? Then we are boiling the solution and add concentrated nitric. Then we are adding ammonium chloride and ammonium hydroxide. A reddish brown precipitate is formed. You know what is the reddish brown precipitate? That can be, that is ferric hydroxide. But we don't know whether it is Fe2 plus or Fe3 plus. Why? If Fe2 plus is present there, when we are in concentrated nitric, it can convert to Fe3 plus as well. Initially Fe3 plus තිබ්බත් එයා positive දෙන්න පුළුවන්. 2 plus can also convert to 3 plus එයා දෙන්න පුළුවන්. So still we don't know. හරි. එක්කෙනෙක් ගැන 100% idea එකක් නැහැ. Can be 2 plus or 3 plus. Then filter the precipitate and H2S is passed through that one. අන්න අපි දන්නවා. When we pass in H2S, a pink color precipitate obtained, that is manganese. So one cation is manganese. When we, after that, we add in ammonium hydroxide, ammonium carbonate, clear solution, no group 5. Sodium hydroxide add කරනවා කියනවා initially. A dirty green precipitate obtained. ඒක උගුල්ලෝ දන්නේ නැහැ තාම. හරි. ඒක මම ඉස්සරහට කියලා දෙන්නම්. දැක්කනේ? හරි. use වෙන්නේ මේක. හරි. use වෙන්නේ මේක. මේක නැතුවට මුකුත් කරන්න බෑ. හරි. අපි ඉස්සරහට යමු ළමයි. මම හිතනවා දැන් ඔයගොල්ලෝ page 1 2 completed නැති කියලා. Hurry. Guys, here I'm going to skip page number 4, 5 and 6. Okay, I'm going to skip page number 4, 5 and 6. The reason for that one is, hurry, those things containing some physical chemistry sections. Some physical chemistry sections. Hurry. එතුමින්දා අපි යමු group, sorry, page number 7 වලට. Page number 7. Anion analysis කියන section එකට. හරි. Very important section. Anion analysis. Anion analysis. හරි. Anion analysis. අපි බලමු ළමයි. මොකක්ද ඒක කියලා group page number 7 නා. I'm in page number 7 now. හරි. Okay. very important topic here, Lamai. Very important topic. What is the topic? Anions which release gases with dilute acids. Hare. Okay. Now, look at this one. If carbonate anion is present, if we add H plus, it will release carbon dioxide gas. You have to complete the theory here. If there are bicarbonate anions also, it will also release carbon dioxide. Carbon dioxide, I think you know how to identify carbon dioxide. I will discuss that one later. Then came down how we can identify carbon dioxide. What we have to do? We have to pass carbon dioxide through lime water. Initially, a milky color precipitate obtained. When you further pass carbon dioxide through that milky color precipitate, it get dissolved. No issue. If there is sulfide anion, guys, actually it can be aqueous solution or solid, no issue at all. Both will give. If there is sulfide, aqueous solution or solid, when you add H plus, H2S gas evolve. H2S gas, what do you know about H2S? It has a rotten egg smell. Rotten egg smell is there. And if there are sulfite SO3 2 minus AQ or solid, with the addition of H plus, it gives sulfur dioxide. Sulfur dioxide gas. Hari? Ek api toilets wala ena smell එක එම කියලා ගන්නෙ. Hari? එයාත් හරි ගඳ එක්කෙනෙක්. Hari? And also this guy, it is very important lamai. It has bleaching property. It can bleach any wet colored surfaces. පස්ස කතා කරනවා. So worry වෙන්න එපා ඒ ටික. Hari? And if there are nitrite ions, it gives NO2. I think you guys know what is the special character about NO2. All these gases are colorless, but NO2, which is a brown color gas, all these things are colorless. NO2 brown gas. Definitely you have to remember this equation, guys. When you add in H plus acid to a nitrite, initially unstable HNO2 is formed. Initially unstable HNO2 is formed. In A-level exams they ask you to write down this equation. HNO2 is unstable. With the presence of water, it converts to HNO3 and NO. It converts to HNO3 and NO. I think here 2NO. Water awan වෙන්නේ එහා පැත්තට එහෙමනොත් ළමයි. 3 here 1 water. Now it is okay. That NO further react with oxygen to give NO2. These are the reaction. In this one. ඒක වෙනම අපි box කරගමු. ඒකත් important එකක්. You know, a page එකේ උඩින් 7th page එකේ උඩින් කොහේ හරි ලියන්න. The thing happened here is, look at this one. When we add in H plus to carbonate and bicarbonate, carbon dioxide gas evolve. When we add in H plus to dilute acids, actually dilute acids, all these things need to be dilute acid. When you add in H plus, dilute H plus to sulfide, H2S gas is released. Rotten egg smell එකක් තියෙන්නේ. When you add in H plus to SO3 2 minus, sulfur dioxide gas is released. It has bleaching properties. It is a bleaching agent. If NO2 minus is there, it gives nitrogen dioxide, that is a brown color gas. Except for these things, there is another one more reaction lamai. thiosulfate, if thiosulfate is there, when we add in H plus, it goes to sulfur plus sulfur dioxide plus water. Sulfur dioxide plus water. Hey, sulfur, it is not a precipitate. Sulfur is not a precipitate. Sulfur is a turbidity. Harry, turbidity means lamai. It is a precipitate. The particles are quite big, so they deposit in the bottom of the test tube. And you can separate a precipitate here and aqueous layer. But when you go to suspension or turbidity, those particles are quite small. Okay, so they already distribute among the solution. Deposition you cannot obtain. So this is the thing happen in the last reaction. Sulfur turbidity is there. That turbidity can be white or yellow in the pulluvan color. Guys, look at this one. Only these anions, they release different gases in the presence of dilute acids. In the presence of dilute acid, these anions release those gases. There is a different equation system to build NO2. Harry, so write down these things as well. Complete the note here. Could you please read that theory section? Among the above gases, the only colored gas is lamai, that is NO කියලා තියෙන theory එක. That is not NO lamai, that is NO2. Change that section. The only colored gas is NO2. It is a gas with a pungent odor. Carbon dioxide, H2S, sulfur dioxide are colorless. Sulfur dioxide is a gas with toilet odor or smell of gunpowder. H2S පොඩ්ඩක් තියෙන තැන වැරදි. පහළ line එකට ආව නම් හොඳයිනේ. H2S is a gas with rotten egg smells. When thiosulfate is treated with dilute acid, the sulfur precipitate, actually the term is turbidity. This sulfur precipitate is known as a turbidity of sulfur. This means sulfur does not settle at the bottom of the solution but rather spreads throughout the solution in colloidal form. That turbidity appears pale yellow or white. It gives the solution muddy brown color. The colloidal sulfur form here is the non-crystalline form of sulfur known as colloidal sulfur. When we add in dilute acid to anion, if brown color gas release, the anion is NO2 minus. If there is a suspension or a turbidity with a gas, anion is thiosulfate. If we can obtain a gas with bleaching properties, definitely the anion can be SO3 2 minus. If you obtain a gas with rotten egg smell, the gas is H2S and the anion is sulfide. If the gas turn lime water milky, the gas is carbon dioxide. Anion can be carbonate or bicarbonate. Like that, you have to remember. Hurry. Hurry. අපි anion සේරම ඉවර කරලා තමයි අපේ first break එක ගන්න ළමයි. ඒ කියන්නේ අපිට roughly යන්න තියෙනවා up to 14th 15th page වගේ වෙනකම්. හරි. after 14th page එක ගාවට යන්න තියෙනවා අපිට. හරි. okay. මම remove කරන්නද? හරි. Guys, look at this song. These anions, they give these different gases in the presence of dilute HCl. So, they definitely give these gases in concentrated excel also. Highlight කරන්න note එකේ තියෙනවා note කියලා. Since all the above ion release gas with dilute acids, they will definitely release gas when exposed to concentrated acid. Are you okay with that term? Concentrated acids. Okay. Now, let's go to page number 8. Let's go to page number 8. Okay. Lamai, actually these anion, they release these gases with dilute acids as well as concentrated acids. Except these anions, there are three anions. They release gases in the presence of concentrated acids. Only in the presence of concentrated acids. Hari ana note එකේ එහා පැත්තේ ඒ කතන්දරය තියෙනවා. ළමයි you can clearly see hari note එකේ තියෙනවා page number 8 වල ඔන්න ඔය මම කියන අලුත් කතන්දරය. මොකක්ද කියන්න බලමු. හරි just give me a second here. Hurry, let me look at this one. Hurry, let me here. If NO3 minus is there, it again give brown color NO2 gas. Sorry, it is brown in color. If I minus is present, it gives I2 gas. Hurry, that is a purple color gas. If Br minus is present, it gives Br2. It is also a brown gas. When you come to A-level chemistry, there are three brown gases. Up to now, we already identified two brown gases. Hari, note එක fill කරන්න ළමයි. Note එක fill කරන්න. Anions that release gases only with concentrated acids. Only with concentrated acids. These are the three examples. Br minus give brown color Br2. I minus give purple color gas, that is I2. And NO3 minus give NO2, which is a brown color gas. Hurry. Guys, I'm going to remove all these things. Hurry. Guys, now we are going to identify some anions and the difference between those anions. Look at the first case. Hurry. Look at the first case. When you come to the first case here, lamai, separately identify NO3 minus and NO2 minus. Hurry. First case එක using dilute acid කියලා තියෙනවා. අපි using dilute acids කියන එක පොඩ්ඩක් දැනට remove කරන්න. Using dilute acids කියන එක දැනට remove කරන්න. Separately identifying NO3 minus and NO2 minus. Okay. අපි ලියමු ළමයි. මම හිතනවා you can balance the redox equations. හරි. Guys, let's separate NO3 minus and NO2 minus by using the first one, acidic permanganate, H plus permanganates. Could you write down the equations? What happened when we add in permanganate to NO3 minus and NO2 minus in the acidic medium? Quickly write down the equation. Sometimes there are no equations. You have to identify the thing. What are the things? When you come to balancing the redox equations, guys, you have to remember few facts. In acidic medium, permanganate, it convert to H plus. Sorry, it convert to Mn2 plus. In basic medium, permanganate convert to MnO2. You definitely have to remember these things. If there are dichromate anions, in acidic medium, dichromate anions, they convert to Cr3 plus. Based on this theory, you can build any equation. Look at this one. I'll help you guys. Hurry. First of all, I am going to balance the second one here. In the acidic medium, permanganate convert to Mn2 plus. Here also Mn2 plus. So guys, you can clearly see this is a reduction. Manganese oxidation state plus 7. Here Mn2 plus oxidation state plus 2. The oxidation state ස්ථාව ගන්න බැරි කෙනෙක් ඉන්නවා නම් මට මැසේජ් එකක් හරි දාන්න. අර 27 2027 ළමයිට ඉගෙනනවා. හරි. ඒතර ඒක බලලා oxidations number ගන්න practice වෙන්න. හරි. Here the gap is 5 electron. Here the gap is 5 electron. Hurry. Plus 7 to plus 2, the gap is 5. You can clearly see there is a reduction. So definitely this guy need to undergo through oxidation. The thing happened here is NO2 minus, it is a strong oxidation agent, permanganate. It goes to its maximum oxidation state. When you come to nitrogen, what is the maximum oxidation state? That is plus 5. So it converts to NO3 minus, the oxidation state is plus 5. So the thing here is, here 5 electron, here 2 electron, here by 2, here by 5. So 5, 5, 2, 2 here, 8 oxygen, 2 into 2, 18. That side contain only 15 oxygen. So 3 water molecules and 6 H plus. Guys, I think majority of you guys know the color of permanganate. That is purple. Sorry, that is purple in color. When you come to manganese 2 plus, that is pale pink, but unfortunately for our naked eye, we cannot obtain this color. So it is colorless. So the observation is when you add in permanganate to a nitrite solution, the color the color of the permanganate solution turn from purple to colorless or very pale pink. What happened with nitrate? In the acidic medium, Lamai, I told you that. In the acidic medium, I told you that permanganate convert to Mn2 plus. Reduction is there. So definitely this guy need to undergo through oxidation. NO3 minus nitrogen in plus 5 oxidation state, it cannot oxidize further. So this reaction does not take place. So when you add in permanganate separately to a nitrate and nitrite solutions, only nitrite turn the color of permanganate from purple to colorless. Okay, space එක චුට්ටක් manage කරගෙන use කරන්න. එතන ළමයි තව ඩයික්‍රෝමේට් එක ලියන්නත් තියෙනවා. හරි. පොඩක් අර sticky notes ටිකක් හරි use කරගන්න එක මට කියන්න බැරි වුණා කලින් ඔයාලට. හරි. එහෙනම් first one එක ලියන්න මෙහෙම. Now we are in the page number 8. 3 කියන section එක separately identifying NO3 and NO2 minus using a dilute acid කියන එක අපි remove කරා. හරි. එතන ලියමු ළමයි. Separately add permanganate, separately add acidified permanganate to NO3 minus and NO2 minus NO3 minus and NO2 minus only NO2 minus turn the color of permanganate from purple to colorless. හරි. ළමයි quickly write down the equations. හරි. ඉවර කෙනෙක් ඉන්නවා නම් ළමයිනේ you have to separate these two anions by using acidified dichromate. Hurry. Using that theory, build the reactions. Using that theory, I'm going to remove this one here. Hurry. I'm going to remove this one. Here these things as well. Hurry. Here, H plus dichromate, Cr2O72 minus. Hurry. You have to build the equations. Dichromate with NO3 minus. I'm going to remove this one as well. Hurry. Dichromate with NO2 minus. I told you that in acidic medium, dichromate will reduce to Cr3 plus. Based on that theory, can you quickly write down the equations? Can you quickly write down the equations? අපි මුලින්ම ටිකක් පැය 6 වැඩි ටිකක් මුලින්ම 3 hours වගේ cover කරගෙන ඉමු ඈ. හරි. ඊට පස්සේ මම 30 minutes විතර වගේ break එකක් දෙනවා. ඉතින් 30 minutes break එකක් දීලා ඊට පස්සේ ආවේ නැත්නම් ඉතින් no videos. හරි. No recordings are available. හරි. only the live session. Only the live session. Hurry. අල්ලගෙන ඉන්නේ ඉතින් ලකුණු 20ක් විතරනේ A level exam එකෙන්. හරි. Write down these equations. Guys, have you balanced these redox equations? According to the theory, dichromate convert to Cr3 plus. It convert to Cr3 plus. So it reduces, the other guys need to undergo through oxidation reaction. So NO2 minus oxidized to NO3 minus, no issue at all. Because here, nitrogen contain plus 3, it can go to plus 5. When you come to chromium, guys, here oxidation state is plus 6, so there are 2 chromium. So when you balance in this one, here also you have to consider 2 chromium. So here, plus 3 is the oxidation state, 3 into 2. This guy reduces, you can clearly see 6 into 2, 12 electron. Here 6, so the electron gap is 6. So no need to draw these curves and those things. Here gap 6, here gap 2. So 2 you have to multiply by 3. So 3 nitrate, 3 nitrate, 3 nitrite. And here the 6 on confused again on 2. Here 6. So 6 by 1, 2 by 3. So here by 1, here by 2. Then you have to balance the oxygen. Total 7, 7 plus 6, 13. Here 9. So 4 water, and lamai, 8 H pluses. So this is already balanced now. Hari, it is already balanced. Hari. When you go to this case, dichromate, its color is orange. Hari, that is orange in color. When you come to Cr3 plus in acidic medium, that is green in color. If Cr3 plus aqueous thing, that is purple, but Cr3 plus in the acidic medium, the color is green. I'll explain those things later. Hari. Here, when you come to this one, Hari, Lamai, you can clearly see here there is a reduction. 6 to here 2, 3 into 2. And definitely the other guy need to undergo through oxidation. But unfortunately, you can clearly see here nitrogen in plus 5, so it cannot oxidize. So this reaction won't take place. So when you add in dichromate, separately to NO3 minus and NO2 minus, only NO2 minus change the color of dichromate from orange to green. Observation when add in dichromate, separately to these two solutions, to these anions, NO3 minus and NO2 minus, only NO2 minus, only NO2 minus, only NO2 minus, only NO2 minus, change the color of orange color dichromate to green. Orange color dichromate to green. Hari, I'm going to remove these two reactions. Hari, I'm going to remove the permanganate one here. Let's remove the permanganate. Hari. Okay. Hari. Third one කියලා label කරමු. Third one. Take two separate test tube කියලා තියෙන්නේ. ඒකට third one කියලා දාන්න. We know the theory. Take two separate test tubes containing NO3 minus and NO2 minus and apply dilute acid to it. Reddish brown gas, we know already, it is given by the test tube containing NO2 minus. We previously discussed when we add in dilute acid to NO2 minus, it releases NO2 gas, which is brown in color. While no gas will release from the test tube containing NO3 minus. Using dilute acids, also lamai, we can separate these two. The fourth experiment, actually we cannot use concentrated nitric. We cannot use concentrated nitric to separate these things because both nitrite and nitrate give brown color NO2. Fourth experiment, very important experiment. The brown ring test. I'm going to remove these things. I'm going to remove these things. Lamai, look at this one. Actually, brown ring test, that is the identifying reaction for NO3 minus lamai. NO3 minus. NO3 minus. Guys, here we are adding freshly prepared Fe2 plus and concentrated sulfuric. Look at this one. Right? Initially, we have to take a test tube and we have to add NO3 minus solution. Then you have to add concentrated. You can add Fe2 plus as well. Right? Then you can add concentrated sulfuric slowly, very slowly. Need to flow through these walls. Gravity එකත් එක්ක නෙමෙයි ඉන්නේ ළමයි, free fall එකක් නෙමෙයි. හරි ටෙස්ට් ටියුබ් එක ටර්මිනල් කරන්න ඇන්ගල් මේ vertical කරන්න ඇන්ගල් කරලා තියෙන්නේ. හරි so here හරි when we adding concentrated sulfuric here, initially we can obtain two layers. We can obtain two layers because concentrated sulfuric, it has a higher density, so it goes to the bottom and the aqueous layer that is on the top. Actually, in the interface where these two layers are mixing, two layers are connecting each other, at the interface you can obtain a brown ring. Brown ring. If brown ring obtained, the chemical formula of the brown ring is FeNO 2 plus. That will confirm the presence of NO3 minus. Look at this one, guys. These are the reactions. These are the reactions. I'm going to write down the reactions. Now we have to add concentrated sulfuric to a solution contain nitrate and Fe2 plus. Initially here Fe2 plus you have to add excessively. Fe2 plus convert to Fe3 plus and here NO3 minus convert to NO. अब make a balance करो तो NL माये 2 here 3, here 3, here 1, 2H plus and sulfate. 2H plus and sulfate. This is the reaction. अवलग के नाने होते ना sulfate and 2 water किया लगाने नहीं लगाने sulfate and 2 water. I write down it here. 2 water. Now it's okay. Still there is a problem. Still it is not balanced. 4H plus selling up balance and give me a second. Give me a second. Oxygen balance the balance of 5. No, here there are total 8, no? 2 sulfate then. 2 sulfate. 2 SO4 2 minus and 2 water. Only now it is okay. Let's check. Here charge minus 1. Here plus 6. Plus 5 is the total charge. Here plus 9. Minus 4. Plus 5 is the total charge. Total oxygen. Here 8. 3 11. 8. 2 10. 1 11. That is okay. Look at the reaction, guys. When we add in concentrated sulfuric in the presence of excess Fe2 plus to a solution contain NO3 minus, initially Fe2 plus convert to Fe3 plus and NO3 minus convert to NO. Are you okay with that one? But we add Fe2 plus excessively. So remaining Fe2 plus is there. Remaining Fe2 plus is there. It further react with NO to give FeNO 2 plus, which is the brown ring. So look at the reaction again, guys. When we adding concentrated nitric and excess Fe2 plus to a solution contain Fe3 plus to a solution contain nitrate, we can obtain initially 2 layers. In between these 2 layers, at the interface, we can obtain a brown ring that is FeNO2 plus. But if NO2 minus ions are present in the solution, it will interfere the case. හරි. අපි ඒකත් ලියාගමු ඉස්සරහට. හරි. අපි එහෙම ලියාගෙන ඉවරයි. There is a diagram on the page number 8. Hurry. Guys, first tube එක it is vertical, but एक අපි ටිකක් angle කරලා concentrated sulfuric and nitrate Fe2 plus add කරන එක අඳිමු. After that, in the second test tube, hurry, represent two layers. In between these two layers, represent a brown ring. Hurry, it is a ring. The chemical formula of the brown ring is FeNO2 plus. So this is the chemical formula. Write down these reactions as well. Hurry. Are you okay with this one? Page number 9 වලට යන්න එපා. Page number 8 වල මේක balance කරන්න. Write down these equations. Hurry. Write down these equations. මම box එකක් අතර ලියුවේ second equation එක. හරි නැත්තම් පටලයි කියලා. හරි. What we are doing? We have to add concentrated sulfuric and excess Fe2 plus to a solution containing nitrate. එහා පැත්තේ details තියෙනවා. So no need to write down the details. හරි. Then you can obtain two layers. At the interface where these two layers mix, you can obtain a brown ring that is FeNO2 plus. So in the question, they can ask what is the chemical formula of the brown ring. So definitely you have to remember this one. Hurry. So if you write down the equations, initially NO3 minus react with Fe3 plus, convert to Fe2 plus and NO. That NO further react with remaining of Fe2 plus in the mixture, because previously I mentioned you that Fe2 plus is excess in the solution, and form the brown ring. Hurry. And the reaction එක ලියවද? Are you okay with that one? හරි. තමයි අපි මෙහෙම කරමුද? එහා පැත්තේ තියෙන විස්තරේ චුට්ටක් හරි. type setting එකේදී පොඩි confuse වෙච්ච ගතියක් තියෙනවා. ඒකේ page 9 එකේ උඩම තියෙන section එක අපි remove කරමු. මම ඒකේ note එක දෙන්නම්. Page number 9, remove that upper section up to Devada's alloy test. Hurry, up to Devada's alloy test. Remove all the theory. एक red pen එකක් cancel කරලා දාන්න. අර මන් දෙනවා හරි. leave note එක මෙහෙම මෙහෙම. හරි. Have write down these equations. හරිනේ. ලියන්න මෙහෙම. When concentrated sulfuric අපි ලියන්නේ හරි. When concentrated sulfuric is added, when concentrated sulfuric is added along the inner walls of the test tube containing NO3 minus and Fe2 plus, containing NO3 minus and Fe2 plus, a brown ring. Again, write down the chemical formula. Definitely you have to memorize the formula. FeNO 2 plus is the chemical formula. Within bracket write down. A brown ring. A brown ring. A brown ring. FeNO 2 plus. A brown ring forms at the interface. Forms at the interface. Forms at the interface where the two layers are mixed. Where the two layers are mixed. Two layers are mixed. Okay, Lamai. Guys, look at this one. This is a very important theory point. For this observation, if NO2 minus ions are present in the solution, that will interfere. Sorry? If NO2 minus is present in the initial mixture, the whole solution convert to brown color. You cannot obtain layer, you cannot obtain a ring as well. NO2 minus interfere for the brown ring experiment. For the brown ring experiment. If NO2 minus is present, if NO2 minus is present, NO2 minus is present, if NO2 minus is present, it produces a deep brown color. It produces a deep brown color. It produces a deep brown color. Deep brown color throughout the deep brown color throughout the entire solution. Brown color throughout the entire solution. Okay, guys, so definitely if NO2 minus is present with NO3 minus, to obtain the brown ring, first of all you have to remove the NO2 minus. How you can remove NO2 minus? Give me a suggestion. How you can remove NO2 minus? We can add excess dilute acids. In the presence of excess dilute acids, NO2 minus convert to NO2. Ekat lihat na, lihat na. If the solution contain both NO2 minus and NO3 minus, if the solution contain both NO2 minus and NO3 minus, both NO2 minus and NO3 minus, to obtain the brown ring, we have to add excess dilute acids. Excess dilute acids. In the presence of excess dilute acids, NO2 minus AQ, you guys know now, it convert to NO2. It convert to NO2. हेට क्लासेस උත්නේ හරි ස්කූල්ස් උත්නේ හරි ඒක හින්දා ප්‍රශ්නයක් නැහැ හරි කුමාරි වැඩි අල්ලන් ඉන්න හරි ඉවරලා ඉතින් නිදා ගන්න තියෙන වෙන අවුලක් නැහැ නේ හරි චොන්ටි ඉවරලත් කීයට වුණත් නිදා ගන්න තියෙන්නේ හරි මට එහෙම නැහැ හරි මගේ ටයිම් ටේබල් එකේ එහෙම නැහැ මගේ ටයිම් ටේබල් එකේ හෙට තියෙන්නේ ට්‍රිප් එකක් යන්න. ගාල්ල යන්න තියෙනවා ට්‍රිප් එකක් 4 am. ඔයාලගේ ක්ලාස් එක ඉවරුණා, ලෑස්ති වුණා, ට්‍රිප් එකක් ගියා. හරි. ඒකට ගාල්ලෙන් එන්නේ මන්ඩේ ගොඩක් රෑ වෙලා. හරි. ඒකට මෙහෙ වෙනකොට ආයෙ ටියුස්ඩේ වගේ වෙනවා. ඉතින් ආයෙ ටියුස්ඩේ ඉඳලා සෙපරේට් ටයිම් ටේබල් එකේ ක්ලාසස් ටික තියෙන්නේ. හරි. ඉතින් හරි ට්‍රිප් එකක් තමයි. ඉතින් ඒ වුණාට ඉතින් නේ හරි එහෙම වැඩ කරා කියලා ප්‍රශ්නයක් නෑ ළමයි. එහෙම අවුලක් නෑ. වැඩ කරා මානසික. ඒක කරොත් මේක ගොඩ දාන්න පුළුවන්. හරි. හරි. නයිට්‍රේට් ගේ බවුන්ඩින් ටෙස්ට් එක්ස්පෙරිමන්ට් එක හරි. මේකත් නෙමෙයි පොයින්ට් ෆෝම් එකක් දාලා. හරි. Brown ring test is a identification test for nitrate. Identification test for nitrate. ළමයි අපි ඊළඟ එකම එක අපි අංකේ දාන්න වෙනදේ 5th one කියලා. හරි. Deodas alloy test. A real important equation. Usually this equation මේක calculations වලින් එකක්. redox වල ඔයා හරියට bogus කරනවා. ළමයි both nitrate and nitrite release ammonia gas in the presence of aluminium powder. Here aluminium convert to aluminate and nitrate and nitrite convert to ammonia. When you come to ammonia, when you come to ammonia, that is really important. Note ammonia is the only basic gas in A-level syllabus. A-level chemistry syllabus. That is the only basic gas. No any basic gases are there. How you can identify a basic gas? By adding litmus. What is the color change? Red litmus turn blue. Using litmus papers you can identify ammonia. There are experiments also. After these reactions පොඩ්ඩක් එතෙන්ට ගිහිල්ලා අපව ආය පාත් එකට එමු. හරි. Okay ළමයි යන්න ඊළඟට Deodas alloy test. Go through the note. The Deodas alloy test cannot be used to separately identify NO3 and NO2 minus. Yes. The reason both nitrate and nitrite release ammonia during this test. I think it's better to underline that section, no? NO3 minus, NO2 minus, both release ammonia with aluminium powder in the basic medium. Okay, guys, following space එකේදී තියෙනවා note එකක් කියලා එකක්. ඒකට යටින් තියෙන space එකක්. මට equations දෙක balance කරලා දෙන්න. You have to balance these equations in basic medium. Quickly balance the equations. So thing happen here is when you add in aluminium powder in the presence of a base to a nitrate solution or nitrite solution, ammonia gas release. Quickly balance the thing. एक मिनट balance करा. मैं विनाडी देखा तो रात देना. Can you quickly balance these two equations? But you have to use a basic medium here. Hari. Now have you balanced the equations? Have you balanced the equation? Hari. It is not a hard equation. Hari, look at this one. Hari, look at this one. Here am I. I'll use in the blue color here. Oxidation state of nitrogen, it is +5. Here -3. The gap between +5 to -3, that is 8. Here aluminium 0. Eliminate +3. Here the gap is 3 electron and here the gap is 8 electron. So here you have to multiply by 8 and here multiply by 3. So 3 ammonia, 3 nitrate, 8 aluminium, 8 aluminate. Now look at this one. Now you have to balance this one in the presence of basic medium. So you can use only OH minus and water. Hurry. You can use only OH minus and water. You can clearly see here total charge is -8. Here the total charge is -8. Here the total charge is -3. To balance the charge, you have to add 5 OH minus to this side. 5 OH minus to this side. And also, to balance hydrogen, there are total 9 hydrogen. You have to add water toward this side. So 2 water molecules. It is 2 water molecules. Now it is okay. Let's balance this equation. Nitrite convert to ammonia. Nitrite +3, ammonia -3. The gap is 6 electron. Here 0, here +3, here 3 electron. 3 by 2, 6 by 1. So 2 aluminate, 2 aluminium, 1 nitrite, 1 ammonia. So if we balance the thing, here the charge is -1 into 2, -2. Here the charge is -1. So definitely in this case you have to add 1 OH minus here to balance the charge. There are total 3 hydrogen, here only 1. So you need to add 2 hydrogen, so you can add 2 water. Oxygen total 4. 2 water away, that is 1 water. Now it's okay guys. Now 1, 2, 3, 4 water. Oxygen, the other side also contain 4 oxygen. Are you okay with that one? Hurry. So look at this one. In the presence of aluminium powder, hurry, both nitrate and nitrite in basic medium convert to ammonia gas. Hurry. अब एक लिया आगे नहीं बोला माई. हरी. एक तो underline करन ला माई. make a underline करमो. हरी. Balanda, the data alloys cannot be used to separately identify NO3 minus and NO2 minus. This is because both NO3 minus and NO2 minus release ammonia gas during this test. Data's alloy is a mixture of containing powdered aluminium copper zinc in alkaline medium. If only powdered aluminium zinc is used, underline calendar, you need fine particles. Only aluminium and zinc powder is used in an alkaline medium. Ammonia gas will release. Hurry. Our equation में balance कर बोला मैंने. Hurry. Guys, not only aluminium, you can use zinc as well. If you use zinc convert to zincate and ammonia. Sorry. If NO2 is also there, zinc convert to ZnO2 2 minus and ammonia. Quickly balance these things. I give you sufficient space here. Sorry, in the page 9. No equations, write down in page 9 again. Use your space and balance these equations. Again in the basic medium, if we use powdered aluminium or powdered zinc, powdered aluminium or powdered zinc in the presence of basic medium to nitrate solution or nitrite solution, you can obtain ammonia gas. Quickly, Anna, ikwan karan. Balamu quickly balance karanna. With the addition of zinc powder or aluminium powder, these anions they convert to ammonia gas. There are few methods to identify ammonia. After these two equation, let's go to that section. Hari, how we balance these equations, Lamai? How we balance these equations? Look at this one, Hari. Lamai, really easy. Here nitrate plus 5, here ammonia minus 3. The gap from plus 5 to minus 3, it is 8. Here zinc 0, Zn auto 2 minus, that is plus 2. That gap is 2, the other gap is 8. So 8, again, here 2, you have to multiply by 4. Here the gap is 8, no? It is by 1. So 4 zinc 8, 1 ammonia, nitrate. Now the charge, you have to balance in basic medium. So 7 OH minus, you can clearly see the total charge here minus 8, here minus 1, 7 OH minus. Now water to this side, H2O, I think 2 water. Now total oxygen is okay, that is okay. If you balance this equation, plus 3, the gap is 6. Here zinc 0, Zn 2 minus plus 2, 2 here, 6 by 1, 2 by 3, here 3, here 3, here 1, here 1. Total 6 OH minus, minus 1 here, so 5 OH minus. It is 5 OH minus and 1 water molecule. Okay, so look at this one. Both nitrate anion and nitrite anion in the presence of powdered aluminium or zinc, they convert to ammonia gas. They convert to ammonia gas. Hari, from page number 9 to Lamine, let's quickly go to page number 21. Let's go to page number 21. Page number 21. Lamai, there are few methods to identify ammonia gas. Quickly, the page number 21. Look at the thing. Test for identifying ammonia gases. I told you ammonia gas is the only basic gas in A-level syllabus. So it turns red litmus papers to blue. The color change is red to blue. Guys, and there is another test that is using Nessler reagent. That is using Nessler reagent. Nessler reagent is a colorless reagent. In the presence of ammonia, underline karanna, Nessler reagent turns brown due to formation of a brown precipitate. If you expose ammonia gas to Nessler reagent, it convert to a brown color. Okay, using Nessler reagent we can identify ammonia. In the third one, identification using an HCl acid containing a bottle cap. A glass rod dipped in HCl exposed to ammonia. The white film of ammonium chloride. Hurry. We will take a write down, guys. Hurry. A white thick smoke. A white thick smoke. It is like this. Assume you are having a glass rod. Okay. So this glass rod, assume it contains HCl droplets. HCl droplets. If we expose this glass tube to ammonia gas, the thing happen here is ammonia gas react with HCl and convert to ammonium chloride. Actually, ammonium chloride is a white color solid smoke. So here you can obtain a white smoke, that is ammonium chloride solid. Solid draw this diagram and write down the equation. There are three methods to identify ammonia using litmus papers. We can identify red litmus turn to blue. The second method using a reagent called Nessler. Okay, Nessler reagent turn to brown. And also we can expose a glass rod which is moist by HCl to the ammonia gas. You can obtain a thick white smoke, that is ammonium chloride. These three experiments confirm the presence of ammonia gas. Are you okay with that term? Hurry. Presence of ammonia gas. හරි ළමයි අපි ආයෙම හිටපු තැනට යමු අපි දැන් යන්න තියෙන්නේ page number 10 එකට. Let's go to page number 10. Page number 10. Okay. ළමයි, I'm going to remove all these things. Now we having a proper idea about two anions. Those are nitrate and nitrite. We have a proper idea to separate, to identify these two anions. Guys, we discussed two anions. Before going to the break, we have to discuss something close to 7 to 8 anions are there. Quickly on Nabi. Anions take ඔක්කොම ඉවර කරලා තමයි first break එකට යන්නවා. හරි 30 minutes දෙනවා. හරි break එක. හරි 30 minutes break එකක් දෙන්නම්. තාප විනාඩි 59යි තියෙන break එකට. හරි 59 minutes. ඒ විදිහ අපිට ඔක්කොම ඉවර කරන්න පුළුවන්. This anion section, එයාගේ validity එක out of final 100, something close to again 4-5 marks ළමයි. Very important section. හරි. ළමයි, look at this one. We previously discussed if we add dilute acid to aqueous sulfide or solid sulfide, H2S gas release. Okay, you have to complete the diagram here. H2S gas is released. You know, H2S gas, it has a characteristic smell, that is rotten egg smell. Fill karagana first section. When you are in dilute H+, H2S gas is released. Okay, H2S gas is released. When you add in silver plus Ag plus, you can add silver nitrate or silver acetate. Ag2S precipitate obtained, that is a black color PPT. Black color precipitate. Are you okay with this, sir? Now may represent करे gas एकक, may represent करे precipitate tag. In some past papers, guys, they ask you to mention gases by using this symbol and precipitate by using this symbol. एक हालत है ना संभारे लावला, अरे, okay. When we add in Pb2 plus, we know already lead sulfide is a black color precipitate. It is a black color precipitate. With sodium nitroprusside, formula not necessary, you can obtain blue purple complex. Blue purple complex. Only the term sodium nitroprusside and the color, that is enough. No need to memorize the formulas and those things. Are you okay with that? Hey, when sulfide goes to the sulfide gava right hand side के उड़े नोट के इतने टिकाक हरी एक अभी complete करना है हदाने लम्हाई when we expose sulfide, usually sulfide OH2S contains same oxidation states, no? Sulfur no? -2 ne? It goes to 0. It converts to sulfur. I told you sulfur is a colloidal suspension. So it is not a precipitate. It does not go to the bottom. It go throughout the solution. That is called a suspension or a colloidal thing. Guys, quickly write down these equations. Try to build the products here. Try to build the products here. So I am using H2S. I am using H2S. And try to identify the observations. Quickly, you need to go through these things. Now I gave you the theory. H2SO sulfur convert to H2SO sulfide convert to sulfur. Previously, I told you a theory point to build equations. What is that theory point? Permanganate in acidic medium, it convert to Mn2 plus. In basic medium, it convert to MnO2. Dichromate in acidic medium, it convert to Cr3 plus. There is no any specific reaction under the basic medium. Okay. Try to build the equations and quickly balance these things. Hurry. Equal balance कर मुझे पे, sorry. Okay, what happened here? Permanganate convert to Mn2 plus, while H2S convert to sulfur. එතකොට මේක හිතෙන් බැලන්ස් කරන්න ගුරු වෙන්න ඕනේ. හරි? හිතෙන් බැලන්ස් කරන්න ගුරු වෙන්න ඕනේ වේගෙන්. හරි? හරි? හිතේ වේගෙන් බැලන්ස් කරන්න හුරු වෙන්න. හරි? ළමයි 25 අයගේ කොහොමත් ක්ලාසස් මේ ටික ඔන්ලයින් යන්නේ. හරි? මේ ටික ඔන්ලයින් යන්නේ මම රිසෝසස් ටික දානවා, පේපර්ස් ටික දානවා. 25 කෙනෙක් ඉන්නවා නම් මම මේ කියන්නේ සෙමිනාර් එකේ. හරි? ඒක ඔන්ලයින් යන්නේ. හරි? අන්තිම මාසේ මම කාටවත් ඒක ෆිසිකල් කරන්නේ අපි මේ වෙනකොටම හරි 25 බැච් එකේ අපි පේපර්ස් අහන ගානක් ඉවරයි. තියරි ඕනම පාඩම් ටික මුලින්ම ඉවර කරලා දුන්නා. හරි? පාස් පේපර්ස් 2004 වගේ ඉඳලා අපි ඩිස්කෂන් එකක් ගිහිල්ලා තියෙනවා. ඒ ටික ඕකේ. හරි? ඒ ටික ඕකේ කරලා තියෙන්නේ. හරි? මහන්සි වෙලා වැඩ කරොත් ඔයාලට ගොඩ දා ගන්න පුළුවන් මේක මේ බැරි දෙයක් නෙමෙයි. හරි? හරි. quickly balance කරමු. හරි? +7 +2 H2S කිව්වහම -2 0 පොඩි උන්නේ no need to draw curves. +7 to +2 gap it is 5 electron, you know that one. -2 to 0 the gap is 2, so 2 by 5 5 by 2. Hurry, it is like this. These are in acidic medium, not the basic medium. Hurry, that's why permanganate convert to Mn2 plus ni. Hurry, so 8 oxygen, which means 8 water. So total 16 H pluses, 10 here, 5 to 10, so 6 H pluses. Hurry. What is the color change again? Here purple, hurry. Here colorless. I told you Mn2 plus contain a very pale pink color, but is it a colorless clear solution? Is it a colorless clear solution? No, this is not a colorless clear solution. This is a colorless solution with the turbidity. The reason sulfur suspension is there. Are you okay with that one? So colorless, within bracket write down with a turbidity. With the turbidity. Okay, what is this equation? Okay, what are the product? I told you dichromate convert to Cr3 plus and H2S need to convert to sulfur. 2 chromium is there. So here also you have to consider 2. 2 into 3, which is +6. Here +6 is the oxidation state of 1 chromium. So +6 into 2 +12. The gap 6. Here -2. Here 0, it is 0. So the gap is 2. Here gap is 6. So 2 by 3. Here 3, here 3. Here this 2 here, here 1. 7 molecules. 14 H plus, there are 6, so which mean 8 H pluses. What is the observation here? Is it convert to orange color solution to clear green color solution, or orange color solution to a green color solution with the turbidity? What is the proper term? Green color solution with the turbidity. Are you okay with that? So here write down dichromate orange, here green with a turbidity. With a turbidity. Hurry. Are you okay? Are you okay, Lamai? Hurry. Okay. Only S2 minus is okay. Lamai. Now let's go to SO3 2 minus. Can I remove this one? Okay. I'm going to remove all these things now. Here. And these things also. Here also I'm going to remove. Hurry. Hurry. Now look at this one. New anion is SO3 2 minus. I told you what happened when we add in H plus. What happened? It converted to sulfur dioxide. Sulfur dioxide contain toilet odor, nathang gunpowder smell like that. Hurry. And within bracket, Israel liyaganna. Hurry. ගොඩක් ඉස්සරහට යන්න එපා reactions තියෙනවා H2S වල වගේ. Israel liyaganna. Bleaching agent. Sulfur dioxide is a bleaching agent. Hurry. Bleaching agent. Decolorize. මෙහෙට පා ගොඩක් equations ලියන්න ඉඩ තියෙන්නේ right hand side පාලෙන් ලියන්න. හරි. Decolorized with colored surfaces. Decolorized with colored surfaces. Decolorized with colored surfaces. Are you okay with that? Okay. Lamai, with silver nitrate, it gives silver sulfite, which is a white color precipitate. With Pb2 plus, it gives lead sulfite. It is also a white color precipitate. Write down that one. The last one is the most important reaction. Out of SO3 minus. Lamai, if we add barium 2 plus to SO3 minus, initially a white color precipitate barium sulfate is formed. A white color precipitate barium sulfate is formed. This precipitate dissolve in dilute HCl. So solid goes to AQ. This is dissolve in dilute HCl. Very important reaction එකක් කියන්න යන්නේ. Past papers majority anion වල තිබ්බ තැනක්. Guys, but you have to remember this one. When you add in barium 2 plus to a sulfide solution, barium sulfide white color precipitate form, it dissolves in dilute acids. But before adding barium 2 plus, if we treat SO3 minus with hydrogen peroxide, SO3 minus convert to SO4 minus and hydrogen peroxide reduced to water. Then we treat with barium 2 plus. I'll give the theory here. So now it write down. Wait. A white color precipitate again form, which is barium sulfate. Again, that is a white color precipitate. But remember, this guy does not dissolve in dilute acids. Hari. Bagi tera up to now me point එකට යනකන් ලියවනේ. Hari. එයා පැත්තේ right hand side එකේ space එක use කරපු ළමයි. Right hand side space use කරපු. Let's use the space. Hari. ළමයි ලියන්න. ආයෙම ලියමු. Barium sulfide BaSO3 dissolve in dilute acids. Dissolve in dilute acids. Hurry. Dissolve in dilute acids. But if we add hydrogen peroxide, H2O2, hydrogen peroxide But if we add hydrogen peroxide to SO3 2 minus solution, to SO3 2 minus solution, then followed by barium 2 plus, then followed by barium 2 plus, then followed by barium 2 plus, a white color precipitate within bracket BaSO4, previously BaSO3, now BaSO4, a white color precipitate BaSO4 is obtained, which does not dissolve in dilute acids. Obtain which does not dissolve in dilute acids. So the thing happened here is, by the addition of hydrogen peroxide, lamai, SO3 2 minus oxidized into SO4 2 minus. Now it is not SO3 2 minus, so it is not barium sulfide precipitate. With the addition of barium 2 plus, it goes to a new precipitate that is called barium sulfate. Remember, barium sulfide that is dissolved in the presence of dilute acids, but barium sulfate that does not dissolve. ප්‍රශ්න හරියට අහනවා. හරියට අහනවා. මේ මාසය තුළත ඉනෝගනික් වැඩ ටික කම්ප්ලීට්ලි ඉවර කරගමු. හරි. ඒ පාස් පේපර්ස් කරන දේවල් ටික කරලා හරි MCQ වල තියෙන දේවල් හැමදේම මම කරලා දෙනවා. අද තියරි එක හැබැයි ඒක නැවත රිපීට් වෙන්නේ නැත. හරි. රෙකෝඩින් නැත රිපීට් වෙන්නේ නැහැ. ඒක ඔයා හරියට කට්ට කාලා ඉතින් උගේ සක් හැරලා හිටියා කියලා ළමයි ඒ ප්‍රශ්නයක් වෙන්න ඕනේ. හරි. ඒ එහෙමත් බැරි නම් හරි වැඩක් නැහැනේ නේ. ඒවත් බැරි නම් වැඩක් නැහැ. අද දවස් හතරට ඔක අහගෙන ඉඳලා නෝට් එක කම්ප්ලීට් කරගෙන ඒ මොරල් එක තියෙන්න ඕනේ. හරි. ඒ මොරල් එක තියෙන්න ඕනේ. හරි. අපි වැඩ කරා ඒ ලෙවල්ස් වලදී. මාර වැඩක් කරේ. හරි. ඒක දන්නවට මම කියලා තියෙනවා. හරි. අපි වැඩ කරපු විදිය. ඒ ලෙවල් මරීගෙන වැඩ කරා. හරි. ඔලේ කාලේ හැම වෙලේම තිබ්බ බ්ලේන් එකක් විතරයි. ඔයා වැඩ කරන්නේ ගෙදරින් කියපු දේ. හරි. වැඩ කරන්නේ ඔහොම ගියොත් ඉවරයි ඔක්කොම. පවුල් නම්බුවත් එක්ක ඉවරයි. ඔහොම තමයි බැන්නේ ඔලේ කාලේ අපිට. හැබැයි ඔලේ කාලෙදී අම්මලා කිව්වේ අසනීපේ නිදා ගන්න. හරි. ඒ තරම් අපි චේන්ජ් එකක් දුන්නා. ඒක දැනෙන්න ඕනේ. හරි. වැඩ කරලා මහන්සි වෙන්න. හරි. හරිද? SO3 2 minus totally okay now. Hurry. Let's go to another anion. I'm going to remove these sections here. Hurry. Let's go to another anion. Hurry. ළමයි අපි ඊළඟ anion එක දැන් චුට්ටයි anion ටිකයි තියෙන්නේ. හරි. ඊට පස්සේ හොඳ බ්‍රේක් එකක් ගමු. හරි. මාත් ගන්නවා ඔයාලත් ගන්න. හරි. හරි. Here look at this one. Thiosulfate S2O3 2 minus thiosulfate. lamai we previously discussed this one. If we add dilute H plus to a thiosulfate solution, what are the reaction, what are the products? I told you sulfur can obtain. It is a colloid suspension, not a precipitate. Do not go to the bottom. It spread throughout the solution. And sulfur dioxide, okay, gunpowder smell like a, and it produces water. Hurry. Lavai. When you add in Silla plus here, okay, initially a precipitate called Silla thiosulfate is produced. When you add in Silla plus to a solution contain thiosulfate. When you add in silver plus to a solution contain thiosulfate, initially, guys, look at this one. Here it can be yellow to white, guys. The color can be changed. That is depend on the size of the particle. Size of the particle depend on the temperature. Here when we come to silver thiosulfate, that is a white color precipitate. White color precipitate. But this white color precipitate suddenly convert to a black color precipitate. That is silver sulfide. It is a black precipitate. So you need to write down this reaction with water. Here we are write down H2SO4. H2SO4. Are you okay with this one? The same thing happened with Pb2 plus. Same thing with Pb2 plus. Equally, lead thiosulfate is formed. That is also a white color precipitate, guys. And suddenly, actually no water here. No water here. It convert to lead sulfide and sulfur trioxide. This is a black color precipitate. Are you okay with that? So really important reaction. When you add in Ag plus Pb2 plus to thiosulfate solutions, we can obtain white color precipitate initially, respectively silver thiosulfate, lead thiosulfate. But after 1 to 2 minutes, that color, white color suddenly convert to black. The reason for that one is these thiosulfates convert to the relevant sulfide. Are you okay with that? Okay. So write down these reactions. One thing reaction I will explain karanna. That is the most important reaction in entire A-level chemistry syllabus. Hari? Ek nathi A-level exam ekak nata. Ek nathi A-level exam ekak nata. Hari? හැම A-level exam එකේම A ගාන තියෙනවා. A equation එක තියෙනවා. මම කියන්නම් මොකක්ද කියලා. හරි? Hurry. Guys, that is iodine thiosulfate reaction. That is iodine thiosulfate reaction. Now I'm going to remove this one. When we treat thiosulfate with I2, hurry, thiosulfate with I2. Actually, guys, we are using starch I2 solution, starch I2 solutions. Biolamide toka hambe na manghitanne oxidizing sugar hari I don't know the thing. Moka khari ek tanakadi ඔය වගේ එකක් එනවා. හරි. So I2 and starch, it form a blue color complex, deep blue color complex. The reaction here take place is thiosulfate with I2, it convert to S4O62 minus tetrathionate and 2I minus. Hurry. Wait. මේ පැත්ත අවුලක් තියෙනවා. It's okay. I2 and here 2I minus. Now it is okay. Hurry. Look at this one. If you add iodine starch solution, initially its color is blue color complex. In the presence of thiosulfate convert to S4O62 minus tetrathionate and I2 convert to I minus. This is the most important reaction in entire A-level chemistry syllabus. Hari, make a liagena. Initially, I2 starch solution blue color, it convert to colorless. Hari, we are explaining that section under the unit number 11. Hari, we are explaining that in number 11. Under the chemical kinetic, there is an experiment about this one that is called iodine clock experiment. A very important reaction. Guys, each and every year, this redox reaction is used in A-level chemistry. මේ reaction එක නැති A-level අවුරුද්දක් නැහැ. හරි. හරි important එකක්. So, write down this equation and box this equation. හරි. And draw some star marks here. ඔයාගේ A-level එකේත් definitely අහනවාමයි. ඔයාගේ A-level එකේ definitely අහනවාමයි මේක. Hari. So no need to confuse with these color changes. Initially it is blue color complex. It turned to colorless. Hari. Let's go to that iodine experiment later. So no issue at all. Hari. So thiosulfate also finish. No issue at all. Hari. වැඩේ කොට දාමු ඊළඟ එකට. හරි. ළමයි Indian film industry එකේ හරි especially in South Indian films හරි ඒගොල්ලන්ගේ හැම වෙලේම ලේ තියෙනවනේ blood තියෙනවා හැම වෙලේමනේ හරි ෆිල්ම් වල තියෙන්නේ එහෙමනේ අර කපා ගන්න ඒවා අර මේවනේ තියෙන්නේ හරි කොහොමද වෙන්නේ හරි guys there's a specific reaction in chemistry හරි specific reaction in chemistry if thiocyanate ions හරි this is experiment to identify thiocyanate in the presence of Fe3 plus usually හරි we have to place Fe3 plus in the skin and thiosulfate in knife hari අරක ඉතින් අර මාළු කපනවා වගේ කපන්නේ නැහැ hari normal පොඩි touch එකක් දෙන්න තියෙන්නේ normal පොඩි touch එකක් small touch එකක් hari knife එකේ thiocyanide coat කරලා skin එකේ Fe3 plus coat කරොත් hari a complex is formed Fe HCN 2 plus. Okay, different complexes we can write down in the presence of 1 thiocyanate, 2, 3, 4 like that based on the amount composition of the complex change. Hari. This complex is formed. This is identical to blood. This is 100% identical to blood. Thickness also equal to blood, not only the color. Okay, so when Fe3 plus react with thiocyanate anion, a blood red complex is formed. So if in the chemistry paper something mentioned about blood red complex, definitely the cation need to be Fe3 plus and the anion need to be thiocyanate. Are you okay? No need to write that one. No need to write that one. Hurry. Look at this one. 7th one under the page number 11. Hurry. When Fe3 plus solution is added externally to a test tube that contain sorry. Hurry. Okay. When Fe3 plus solution is added externally to a test tube contain thiocyanate HCN minus then Fe3 plus solution turn blood red. Fe2 plus turn blood red. Initially the thiocyanate solution is colorless, HCN minus is colorless, and it turn into blood red color confirm the presence of Fe3 plus. චුට්ටක් හදාගන්න ළමයි. හරි එතන equation එක ලියමු අපි නැත්තම් test tube එකට හපත්තේ. Fe3 plus with thiocyanate හරි a blood red complex. හරි it is blood red complex is given. හරි blood red complex හරි equation එක ලියා ගන්න. එතකොට ඒක හරි. හරි. If they given a blood red thing, definitely cation Fe3 plus anion thiocyanate. Hurry. Hurry. Guys, if we go to the 8th experiment, that is sulfate. We previously also discussed about sulfate. If we add SO4 2 minus to a solution contain barium chloride or barium 2 plus, or the other way, a precipitate obtained barium sulfate. It does not dissolve in the dilute acids. We discussed that one. If they give a thing like this, anion is present. When adding barium chloride to that one, a white precipitate obtained that does not dissolve in dilute acid. The anion is sulfate. Underline the thing. Hurry. Sulfate with terms की तरह underline करो. Barium chloride, sulfate, BSO4, white precipitate, insoluble in dilute acids. මට කියන්නේ මේ කවුද කියලා anion එක දැන් අපි ඉගෙන ගත්ත එකට touch එකේ ඉගෙන ගත්තා නා. There is an anion. When we initially add in barium chloride, the white precipitate obtained. That white precipitate dissolve in excess acid, dilute acid. But before adding barium chloride, we add in hydrogen peroxide to that anion solution. Again, white color precipitate obtained. Hurry. With the further addition of dilute acids, the precipitate does not dissolve. What is the anion? Sulfite. SO3 2 minus. Now it is sulfate. Are you correct? Hurry. Hurry. Guys, මෙන්න මේක මම එක්ස්ට්‍රා නොලෙජ් එකට දෙන එකක් 9th one අහන්න තියෙන probability එක නැතිම තරම්. හරි. හැබැයි pass paper questions කරද්දී ඔයාලට කරන්න බැරි වෙනවා මේක දන්නේ නැත්තම්. ඒකයි මම මේ question මේක දාලා තියෙන්නේ. දැන් අපේ syllabus එකේ ළමයි phosphorus ගේ chemistry එක උගන්වන්න නෑ under 15. හරි. under 15 group phosphorus ගේ chemistry එක නෑ only about nitrogen. මම සමහර notes දෙකක් දෙනවා phosphorus ගේ මේ chemistry උගන්වලා තියෙනවා විසික් කරලා දාන්න පොත්. ඇත්තටම වැඩක් මේක මේ අනවශ්‍ය දේවල් ෆිල් කරගන්න බෑ inorganic වල. හරි. ෆිල් කරන්න ගොඩක් දේවල් තියෙනවා. Okay, unnecessary things එපා. හරි. But when you go to past paper questions, හරි all syllabus වල තිබ්බා. හරි අපේ syllabus එකේ නෑ. There is a test to identify phosphate. Okay. There is a test to identify phosphate anion. Now we are identifying anions, no? We identify nitrite, nitrate, no? And we go to with carbonate as well, removal of carbon dioxide gas with dilute acids. After that we go to sulfide, SO3 2 minus, thiosulfate, SCN, thiocyanate, SO4 2 minus. Then we kata kar inne phosphate. Hari guys, there is experiment to identify phosphate. To identify phosphate, we are adding a compound like this: NH4 twice MOO4. What is the name of this compound? Ammonium molybdate. Ammonium molybdate. When we add in ammonium molybdate to a solution contain phosphate, a yellow color precipitate is given. Page number 9, underline this section, ammonium molybdate. इधर formula के बड़ी अवलत तिब्बा के मत मतकाई कोहे हरी आये अवलत ये ना diagram में के concentrated nitric ammonium molybdate के लिए NH मत पेन में आती है ने का NH4 डने दी NH4 twice MO molybdenum molybdate make MOO4 2 minus means molybdate. Okay, so underline those things. Phosphate, add in ammonium molybdate. Are you okay with that one? A yellow precipitate obtained. A yellow precipitate obtained. Okay, here you go. Okay, hurry. Yan tayo chuttay. Anions na tikay di mo tawa. Bohoma chuttay. අන්තිම හරිය ඉන්නේ දේ. හරි. දැන් ඇත්තටම මේ මම කිව්වේ එකයි පටන් ගද්දි මම මගේ මැක්සිමම් එෆර්ට් එක දානවා අද දවස් අතරේ මේක ඉවර කරන්න කියලා. හරි. මම මේක ඉවර කරන්න මීට කලින් roughly 8 hours විතර වගේ ගත්ත මේ total tute එක. අපිට දෙන්නේ 6 hours. හරි. ඔයාලා ගෙදර ඉන්න කියලා අද දවසේ මට ඒ chance එක නෑ මේ තව වැඩිපුර කරන්න after 3 am මොකද trip එක යනවානේ. හරි. ඒක හින්දා අපි අපේ පරිමේ try එක දෙමු. මේක ඉවර කරන්න මේබී චුට්ටක් හරි ඉතුරු වෙයි. මම 100% කියන්නේ ඉවර කරනවා කියලා. හරි චුට්ටක් හරි ඉතුරු වෙයි. මොනවද ඒ ටික අපි ඊළඟට passport discussion series එකක් පටන් ගමු. හරි වැඩි ලස්සනට අරගෙන යන්න. හරි මම වැඩි කර දාලා දෙනවා. ඒක බයෙන් දෙයක් නෑ. හරි ඒක වචනයක්. ඒ වර්ඩ් එක මම දෙනවා. හරි එතකොට මේ වාසියරේදී organic fully හදාගමු. හරි organic එක fully හදාගමු. okay එකයි වෙන දෙන හරි ළමයි let's go to the 10th experiment. Test for separately identifying nitride N3 minus. Guys, I'm going to remove this one. Okay. Okay. Hey, look at this one. Sorry. Lamai, do you remember the inorganic knowledge? When you come to S block element, group 1, we know group 1 is known as alkaline metals. Only one alkaline metals react with nitrogen. But all the earth metals, alkaline earth metals react with nitrogen. What is the only alkaline metal react with nitrogen? What is the only alkaline metal react with nitrogen? Lithium. Right? Lithium. Answer 7. Hari. Whatever answers. Hari. WhatsApp through Hari Dan. Hari. මේ ඉන්ටර්වල් එක වෙලාවේ පුළුවන් නම් බ්‍රේක් එක වෙලාව පොඩි කමෙන්ට් එකක් දාලා තියන්න. හරි. මොනවද චේන්ජස් වෙන්න ඕනද මොකද්ද කොහොමද තත්ත්වය පොඩි මැසේජ් එකක් දාන්න. මගේ නම්බර් එක තියෙනවා මම රියට් කමෙන්ට් කරන්න දාන්නේ නැහැ. හරි කාටවත් නිකන් උඩින් බලලා ගමු අපි මොකද්ද අයිඩියා එක කියලා බේසික් එක. හරි. බලන්නකෝ. හරි. guys when we adding lithium nitride hurry to water it convert to lithium hydroxide AQ and ammonia. Hurry. If we balance this on 3 here and 3 here, hurry. If we write down magnesium nitride, also I can write down with water, it converts to magnesium hydroxide, which is a white color precipitate, and gives ammonia gas. Here 3, here 6. Okay. So when we add in any nitride anion to water, it produces ammonia gas. We know how to identify ammonia gas. What are the methods? මට කියන්න බලන්න ammonia gas identify කරන්න තියෙන method තුනක්. I need 3 methods. What is the first method to identify ammonia? You can use red litmus. Red litmus turns blue in the presence of ammonia because we know ammonia, which is a basic gas. Second one, you can use necessary reaction. It turned to brown. The third one, you can use moist glass rod with HCl. You can obtain a white thick smoke. Hari. In a reaction එක තියෙනවා ammonia ගැන එක පංචන් ස්මෙල් එකක් කියලා. ඔව් මේක හරි සරයි ළමයි. හරි මම දන්නේ ඔයාලා කරලා තියෙනවද කියලා. අපි අර ඉස්කෝලේ යන කාලේ යාළුවන්ට දෙනවා ammonia bottle එක. හරි. අපි පොඩ්ඩක් ඈත තියලා ඒක සුවඳයි වගේ පෙන්නලා පොඩ්ඩක් ඇට් එකක් දාලා යාළුවන්ට දෙන ගොඩක් අපි බොක්කේම විශ්වාස කරනවනේ ඒ කාලේ. හරි. උන් ඉතින් අර හොද්දට මේකෙන් අපි විශ්වාස කළා බොටල් එකේ පොඩි අරපු ගමන්ම ළඟට දාලා අදිනවා. හරි එහෙම ඇද්දාම හරි සරයි ඕක. හරි මේ යනවා දැනෙනවා. ඔලුවරි දෙනවා සෑහෙන වෙලාවක් යනකම්. හරි. Okay. Make reactions given. Hurry. But write down these two reactions. Lithium nitride with water, magnesium nitride with water. They give relevant hydroxide. This guy AQ, this guy solid, the precipitate with ammonia. Hurry. So when we add in any nitride to water, it will release ammonia gas. We can identify ammonia gas using 3 types of experiments. ඉක්මන් කරනද හරි ටෝටල් වැඩේ ඉවර කරගන්න හරි චුට්ටයි තියෙන්නේ හරි චුට්ටක් තියෙනවා තව හරි ඒතර ෆස්ට් සෙක්ෂන් එක ඕකේ ඉන්ටර්වල් එකට කලින් ටික බ්‍රේක් එකට කලින් ඊට බ්‍රේක් එකක් ගන්නවා කියලා ඉතින් නිදා ගන්න හැම යන්න එපා හරි ඉවරයි ඉතින් ඊට පස්සේ ආය උදේ තමයි හැරෙන්නේ හරි බ්‍රේක් එකක් ගන්නවා කියලා නිදා ගන්නවා 30 මිනිත්ස් බ්‍රේක් එකක් දෙනවා කන්ෆර්ම් කරන්න හරියට එක්සැක්ට්ලි 12 දෙකේ චුට්ටක් යන්න තියෙනවානේ ඒක ඉවර කරලා තමයි බ්‍රේක් එක දෙන්නේ කිව්වට හරි 12 10 maximum heavy then 30 minute break hurry after break you can join to the class hurry the hurry okay 11th one lamai when we come to anions of chromium guys there are 2 types of anions one is CrO42 minus, which is yellow in color, and the other one is Cr2O72 minus, that is orange in color. Right? These two are in a equilibrium actually. So if we balance this one, right, it is an equation like this. Here I have to add H plus AQ. Here I have to add OH minus AQ. Hurry. Equilibrium is not totally complete. Hurry. What පුළුවන් නම් මම equation එකක් දීලා තියෙනවා equilibrium එකක් reversible reactions වලින්. ඔයාගේ right hand side chromate ගාව could you write down this equilibrium? Hurry. There are 14 sections in A-level chemistry syllabus. ඔයාලා දන්නවා ඇති හැමෝම මේ වෙනකොට ලොකුම ලකුණක් එන්නේ කීවෙනි section එකෙන්ද කියලා. 12th section. There are 30 marks out of final 100 for the 12th section. Equilibrium. Okay. Under equilibrium lamai, there is a principle called Le-Chatelier. Look at this reaction. This is not an irreversible reaction. It is reversible. This reaction can take place to both directions. If the rates are equal, we consider that system goes to a dynamic equilibrium. Okay. Equilibrium. Term defined. It is a stable case. Okay. So, the equilibrium, this system does not like, hurry, for the external things. Hurry. Usually, hurry, there is a principle that is called Le-Chatelier principle. That is called Le-Chatelier principle. Hurry. Guys, this is equilibrium system. To this equilibrium system, if we add H plus additionally, the system does not like that. System try to against the thing we did. So we are adding H plus, system try to remove H plus. To remove H plus, if it goes backward reaction, H plus producing, which means it goes to the forward reaction. So when we acidify in the system, System favor the forward reaction and orange color is obtained. Are you okay? Not a yellow color. The theory, it is called H-Hartley principle. Write down the equilibrium. Hari. Number one කියලා දාමු ළමයි. Adding H plus to the equilibrium. Adding H plus to the equilibrium. Quickly ලියාගමුද? Adding H plus to the equilibrium. හරි. ලියලා ඉන්න මම එකයි දෙන්නේ. ඔයා අනිත් එක තනියම ලියන්න. හරි. ලියන්න මෙහෙම. හරි. When we add in H plus to the above equilibrium mixture, when we add in H plus to the above equilibrium mixture, H plus to the above equilibrium mixture, system try to remove H plus, system tries to remove H plus according to the system try to remove H plus according to the Le-Chatelier principle. Le-Chatelier principle. So the system favored you can clearly see to remove H plus the forward reaction need to be take place. Okay, so to remove H plus system favor the forward reaction. Yeah, system favor the forward reaction. So an orange color obtain. An orange color obtain. An orange color obtain. Hurry. It's up to you. You have to write down, add in OH minus to the equilibrium. You have to explain the effect. I explain. When we add in OH minus, system try to remove OH minus. They try to do against to the thing we did. Hurry. To remove OH minus according to the Le-Chatelier principle. To remove OH minus, the backward reaction need to be favored. Forward decay more and more OH minus are producing, the backward reaction need to be favored. So yellow color obtained. In basic color, basic medium, it is yellow. In acidic medium, it is orange. Acidic nam basic nam you have to apply Le-Chatelier. Questions will be hanawa. Hurry. Mass target එකත් ගන්න. හරිද? මේ මාසය තුල inorganic ඉවර කරනවා කියන ටාගට් එක. 26 ළමයි. 26 ළමයි ඉන්නවා නම් 26 majority ඉන්නවා. හරි. මම ඊයේ ගණන් හදලා බලුවා. 296 දවස් තියෙන to A-level exam. To A-level exam 296 days are more. අසාධාරණ ඉතින් කරන්න දෙයක් නැහැ ළමයි. අපි මොනව කරන්නද? A-levels දෙක අතර gap එක මාස 3ක් තියෙනවා. මොකද නොවැම්බර් තමයි 25 අයියලා අක්කලාගේ එක්සෑම් එක තියෙන්නේ. ඔයගොල්ලන්ගේ ඕගස්ට්. එතන මාස 3ක් ગેප් එකක්. ඒක ඉතින් අපිට කරන්න දෙයක් නැහැ ගවර්න්මන්ට් එකෙන් දාලා තියෙන දෙන්නේ. හරි. ඔයාට ආගස්ට් තියාගන්න. මේ මාසය තුළද ඉනෝගනික් ඉවර කරනවා. ඊට පස්සේ නොවැම්බර් ඩිසෙම්බර් වලදී ඕගනික් ඉවර කරන්න. හරි. එහෙම නොකරොත් කරන්න බෑ 26 අයට. මොකද ඕගනික් 10th unit කියන්නේ up to 10th unit කියන්නේ grade 12 syllabus එක. grade 13 එහෙමමනේ. grade 13 කියන්නේ unit 4යි 11 12 13 14. sorry.com වෙනවා. හරි. monthly plan වලට ගියේ නැත්තම් මේ month එකේ inorganic මගේ help එක මම උපරිම දෙනවා. මේ ආර organic වෙලෙදියා පුළුවන් එතකොට. හරි. හරි. ළමයිලකට මම හිතන්නේ මේක ඕකේ. හරි. හරි. අන්නකෝ වෙලාව ළඟයි. හැබැයි ඉතින් අපි වැඩි ඉවරයක් කරලා මිමු. හරි. වැඩි ඉවරයක් කරලා මිමු. ඇනවුන්ස් ටික ඉවරයක් කරලා මිමු. හරි. චූටි වෙලාව වෙනවන්නේ. ඇනවුන්ස් ටික ඉවරයක් කරලා මින්න. ඊට පස්සේ බ්‍රේක් එකක් ගමු. හරි. හොඳට බ්‍රේක් එකක් කරලා ඊට පස්සේ වැඩේ කොට දාමු. තව චුට්ටක් ඉතුරු වුණොත් ඒක පස්සේ බලමු. අවුලක් නැහැ. හරි. මේ මම මේක රිමූව් කරන්නද? හරි. ළමයි එතන පොඩ්ඩක් හදාගන්න. Liquid chlorine test to separately identify Br minus and I minus and Cl minus කියලානේ. Cl minus ඒකත් ඕනේ Cl minus කියන එක. හරි. ආගෙන ඉන්න මොකුත් ලියන්නේ නැහැ. Now using chlorine and CHCl3, this compound is known as chloroform. Antimatica, we are going to identify Cl minus, Br minus and I minus. Hari, you can clearly see 3 anions are there. මේ page එක මේකට use කරමු අවුලක් නැත. Total 12 page එක මේ වැඩේට use කරන්න. මම කියන්නේ අහගෙන ඉන්න. Okay, ළමයි. When we mix in Cl minus and Cl2, nothing special thing take place, no. But when we mix in Br minus and Cl2, hurry. Actually, the thing happened here is chlorine contain a higher electronegativity, so it tend to go to Cl minus. Hurry. Here it goes to Cl minus, and Br minus convert to Br2. Hurry. So 2 Br minus. That is the reaction. A same thing happened here. 2I minus with Cl2, it goes to I2 plus 2 Cl minus. Are you okay with that one? These are the reaction take place. Guys, except water, for these anions, we are adding chloroform. Chloroform is an organic solvent. It contains a higher density compared to water. The density is high. Right? So actually, in this case, you can obtain 2 layers. You can obtain 2 layers. Hurry. Bottom, you can identify organic layer CHCl3. Here also CHCl3. Hurry. And here also CHCl3. Actually, when this reaction take place, hurry. Here, these are aqueous layer. Here also aqueous. Also aqueous. Those things are aqueous. Right? The thing happened here is these produced iodine, they extract from aqueous layer to organic layer. Here, produced Br2 come from aqueous layer to organic layer. Here also the same happen. Chlorine is there. It comes from aqueous layer to organic layer. Okay, ගණන් 25 කෙනෙක් ඉන්නවා නම් ඔයාලට මතක ඇති that is based on KD distribution coefficient. අපි මේ ගණන් හදලා තියෙනවා ඇති වෙන්න මේ වගේ ගණන්. හරි? ඒතර ඒගොල්ලෝ ඒක දන්නවා. 26 අය දන්නේ නැහැ. ඒ ප්‍රශ්නයක් නැහැ. හරි? ඒක ඉෂුව එකක් නැත. Very important thing, you can obtain bubbles here. You can obtain bubbles here. Actually, we are considering that one as droplets. Droplet test කියලා කියන්නේ. හරි? topic එකේත් තියෙන droplet test කියලා term එකක්. Here also you can obtain droplets. Here also you can obtain droplets. In the organic layer, you can obtain droplets. Guys, මං ගාවනේ හරි colors තියෙන marker. If I minus initially is there, remember this one, you can obtain purple colored droplets. You can obtain purple colored droplets in the organic layer. Are you okay with that one? If Br minus initial in the aqueous solution, you can obtain orange color Br2 droplets. Hurry. Here also you can obtain droplets, but it is colorless. Hurry. Podi short note එකක් දාගෙන ඊට පස්සේ වැඩි කොට දාගමු ශනිකව. ලියන්න මෙහෙම. හරි. note එකක් දාගමු මෙතන. හරි. ඊට පස්සේ අඳගමු. හරි. අර distribution coefficient කරලා තියෙනවා 25 කෙනෙක් ඉන්නවා නම් ඒගොල්ලන්ට තේරෙනවා මොකද්ද මේ වෙන්නේ කතාව. හරි. I minus Cl minus Br minus I minus නෙමෙයි ළමයි organic layer එකට එන්නේ the produce halogen එකයි එන්නේ not the halide anion. හරි. අපි ලියන්නේ මොකක්ද? හරි. තමයි ලියන්න when Cl minus comma Br minus comma I minus treat with chlorine water and chloroform within bracket CHCl3. This is the chemical component CHCl3 chloroform. Two layers can be obtained. Point form දාලා ලියමු. First point form එක. First point form. If purple color droplets, පුළුවන් නම් දම් පෑනෙන් අඳින්න. If purple color droplets are present in the organic layer, observed in the organic layer, it confirms the presence of I minus. Second if organic layer contain orange color droplets, it confirms the presence of Br minus. Sorry. If colorless droplets obtained in the organic layer, it confirms the presence of Cl minus. Space enough. Write down the reaction and draw these relevant diagrams. චුට්ටයි වීම තව අල්ලන්ගෙමු. quickly ඉවර කර හැකි. චුට්ටයි ටිකක් ඉවර කරලා බ්‍රේක් එකක් ගමු. හරි. Hari, okay, hari. Diagram stick adu, hari. Ini pasti lagi kalian tahu, itu pasti wadi wara ya, hari. Jadi kira-kira berapa? මට හිතෙන්නේ ළමයි අද අපිට මැක්සිමම්ලි හරි ඔය කොහොමත් ෆුලි ඉවර කරන්න අමාරුයි. ඔව් හරි චුටි වෙලාවක් ඒ කියන්නේ අල්ලගෙන ඉන්න මම මේක ඉවර කරලා බ්‍රේක් එකකට යනවා. හරි චුටි වෙලාවක් කොහොම අල්ලගෙන ඉන්න තව චුටි වෙලාවයි තියෙන්නේ. හරි වචනයක් දෙනවා maximally within 15 minutes. හරි within 15 minutes I'll give the break. Hurry. Only 15 minutes. Hurry. Are you okay with this, sir? So, to identify halides, chloride, bromide, iodide, we can use a specific test that is called chlorine water chloroform test. Chlorine water chloroform test. Are you okay with that one? Chlorine water chloroform test. Hurry. And I'm going to break your gum. Mentally relax me. Hurry. Okay, I'm going to remove these things. Hurry. Guys, look at this one. Ilaga page ekata yamu. Ilaga page ekේ තියෙනවා මෙන්න එකක් important points of precipitates කියලා. There are 5 ionic precipitates which are insoluble in dilute nitric. Those are silver chloride, silver bromide, silver iodide, PbCl2, barium sulfate. Their colors also given. Sorry, economy patode. Second one, silver halide. Hi. Then liam mehema topic ekak silver halides going. Liam mehema separation of halide anions. That are separation of halides by using separation of anions by using silver nitrate by using silver nitrate. So silver nitrate, which means it contains Ag plus. So if we add silver plus silver nitrate to a chloride complex, chloride anion solution, it produces AgCl, which is a white color precipitate. If we add silver nitrate to a solution contain Br minus, it gives silver bromide, which is a yellow color precipitate. Right? Actually, that is pale yellow. Right? If we add I minus to a silver nitrate, AgI solid is obtained. That is a dark yellow precipitate. Could you complete this one? When we add in separately silver nitrate to Cl minus, white color precipitate obtained lamai. Br minus, a pale yellow precipitate obtained. I minus, a dark yellow precipitate is obtained. Clear? Very important point. Guys, let's take the first one. Theory is there, underline, really important thing. AgCl dissolve in both dilute and concentrated ammonia. AgCl dissolve in both dilute and concentrated ammonia. Highlight that section. Silver chloride dissolve in both dilute and concentrated ammonia. Are you okay with this one? Write down the reaction. Silver chloride solid in the presence of 2 ammonia, it can be concentrated or dilute lamai. It convert to silver amine complex. Under the organic also that is AQ. Write down the reaction. Space is given. AgCl dissolve in both, underline karanna, AgCl dissolve in both dilute and concentrated ammonia solutions. මම ඉන්ටර්නල් එකේ බලන ලස්සන වීඩියෝ එකක් ගෲප් වල ෂෙයා කරන්න. ඊළඟ එක්ස්පෙරිමන්ට් එකේ තියෙනවා කෙමිස්ට්‍රි වල තියෙන ලස්සනම රියැක්ෂන් එක. හරි. බලමු ඒක. හරි. underline करा guys. AgBr, this one does not dissolve in dilute ammonia, no reaction, but dissolve in concentrated ammonia. Underline करा. When you come to AgBr, it dissolve in concentrated ammonia only. It does not dissolve in dilute ammonia. Underline karan silver iodide. It does not dissolve in both dilute or concentrated ammonia. Does not dissolve in both dilute or concentrated ammonia. Hari. Highlight color diya underline karan. Hari. Before the interval, this is the last anion identification. Okay, using lead nitrate PbNO3 twice. Hari again using Pb2 plus. Guys, we can identify these things. मैं explain करना आगे नहीं ना. Can I मम्मी को move कराने दे? Okay. Hari. Lamai. Look at this one. When you add in Pb2 plus, two solutions contain Cl minus, Br minus, I minus, respectively. PbCl2, a white precipitate obtained. PbBr2, a pale yellow precipitate obtained. PbI2, a dark yellow precipitate obtained. Precipitates obtained. All these precipitate dissolve in hot water. Hari, if you add hot water, they dissolve. They convert to PbCl2 liquid, PbBr2 liquid, PbI2 liquid. All these liquids are colorless lamai. Colorless, here colorless, here colorless. When it cool down, a real nice thing happen. Hari. When it cool to the room temperature, a real nice thing happen. When you come to lead chloride, you can obtain needle-shaped crystals. Needle-shaped crystals. If a term came like needle crystals, definitely cation can be Pb2 plus and ion is Cl minus. Okay, you cannot get a proper observation here. The same thing. Note again, you know, okay. Budiya kain karamu. Menne chemistry lassana experiment that is known as gold rain experiment. I'll give you a link here. Search karla balanna gold rain experiment kiyala. The thing happen here is initially it is a dark yellow precipitate. When we heat this one, the precipitate dissolve, colorless solution obtained. Okay, precipitate is there, yellow color precipitate. When we heat that one, a colorless solution obtained. When it cool to the room temperature, Hari, initially you are having a colorless solution like this. A gold rain can be obtained from the surface. May surface again, Hari lassana gold rain ekak obtained gold rain kiyana wachane awana ko hari tanaka. Hari, gold dust kiyala enna puluwan. Hari, cation is Pb2 plus and ion is I minus. Antimeka before the interval allanginna. Note එක බලන්න complete කරගෙන නේද flow chart එක. Cl minus ඉස්සරහා PbCl2 white precipitate, Br minus ඉස්සරහා PbBr2 pale yellow precipitate, I minus ඉස්සරහා PbI2 dark yellow precipitate. Like that, write down. Sorry. With hot water, Hari, dissolve. Hari. all these solids convert to relevant liquids, they are colorless. They are colorless. Are you okay with that? When it comes to the room temperature again, crystals are formed. In this one, PbCl2 needle-shaped crystals are formed. When you come to lead iodide, gold rain can be obtained. lead bromide, ලොකු ස්පෙෂල් එකක් නෑ. ඔය ටික විතරයි ඉතින්. හරි. quickly ලියා ගන්නවක. හරි. compounds ටික ලියාගත්තා, precipitate ලියාගත්තා. with hot water dissolve වෙනවා කියන එක ලියන්න. room temperature, needle shaped crystals here. Here මේක ලියන්න බැරි වෙලානේ. gold rain crystals. It's a gold rain. මාර ලස්සනක් එක. මම දාන්නම්. හරි. gold rain නම් PbI2, needles නම් BCl2. හරි. ඔන්න වැඩේ හරි. අපි first section එක okay. හරි. first section එක okay. හරි. ළමයි පොඩක් ඉන්න මම වෙලාව බලන්න. හරි. හරි. ළමයි වෙලාව තියෙන 12යි කාලයිනේ. අපි 12:45 වෙනකම් බ්‍රේක් එකක් ගමු. හොඳට බ්‍රේක් එකක් ගන්න. හොඳට බ්‍රේක් එකක් ගන්නවා කියලා අදට කියලා නිදා ගන්න එපා. හරි. 12:45 වලදී last වෙමු. ඉතුරු ටික අපේ maximum force එක දාලා පුළුවන් තරමක් අපි cover කරගමු. හරි. බ්‍රේක් එකක් ගන්න පුළුවන්. හරි. දෙකනම් බ්‍රේක් එකෙන් පස්සේ අපි ඉස්සරහට කන්ටිනියු කරමු. දැන් අපේ ටාගට් එක ඊළඟට වෙන්නේ තාම අපි අනායන් ටෝටලි ඉවර නැහැ. අපේ ටාගට් එක ඊළඟට වෙන්නේ හරි cations. හරි. Before going to cations, guys, a small section is there. Let's quickly go through that section. හරි. ළමයි I'm in page number 14. Hurry. Page number 14. Hurry. I told you previously, chromate anion that is yellow in color. Hurry. Chromate anion, it is a yellow color AQ. Hurry. Topic එක වෙනස් කරමු. Chromium oxide precipitates කියලා තියෙන්නේ. ඒක chromate precipitates කියලා ලියාගමු. Chromate precipitates. Guys, look at this one. Actually, there are 4 chromate precipitate. Hurry. 4 chromate precipitates. Those things are when strontium react with chromate, it gives strontium chromate. When barium react with chromate, that gives barium chromate. And when lead react with chromate, it gives lead chromate. All these chromates are yellow precipitates. Except these things, a reddish brown precipitate is there. Silver chromate is a reddish brown precipitate. Hurry. Write down that one. When you come to chromates, hurry. There are 4 chromate precipitates. Strontium, barium, lead, their chromates are yellow in color. And when we come to silver, it's a reddish brown precipitate. Hurry. Okay, guys. Let's go to chloride precipitate. When you come to chloride precipitates, do you remember in group analysis under the first group, we discussed there are three precipitates. There are three chloride precipitate, Pb2 plus, Ag plus, and Hg2 plus ने आप इतना discuss करें. Okay, so here addition to that cuprous chloride also there. Sorry, lamai Ag plus, Pb2 plus, and mercurous. मैंने मित्रना चोरी mistake का कोई लाते हैं ना. Hg2 plus with Cl minus it gives Hg2Cl2. In the group 1 also we discussed that one. These things are white color precipitates. What the case? Sorry. These things are white color precipitates. AgCl, PbCl2. These things are white color precipitates. Except these things, guys, another one chloride precipitate is there. That is chloride with cuprous. CuCl also a white color precipitate. Quickly analytical hamai. Hari. There are four chloride precipitates. Look what important again at 15 page targalayang. Hari targalayang. Guys, when you come to barium, there are 6 precipitates of barium. Hari, lamai ek balanna. Barium 2 plus. Okay, guys, with sulfate, it gives barium sulfate. Complete karega wo. With oxide, it gives barium oxide, and with chromate, it gives barium chromate. 6 barium precipitates are available. With carbonate, it gives barium carbonate. With phosphate, it gives barium phosphate, Ba3PO4 twice, and with SO3 2 minus, it goes to BaSO3. Hari, look at the ne. Apita ilangeka maravadagat. Ilangeka maravadagat. Hari. Adili agamo. Nami ilaga not take guys. Let's go to page number 16. Page number 16, 17. They are really important. Now, look at this one. I'm going to remove all these things. Okay. Lamai. Because Anna in Nava. Hurry. Because Anna in Nava. Guys, when we add in dropwise OH minus, initially a precipitate obtained. After that, excess OH minus, the precipitate dissolve. Actually, this observation is given by amphoteric metal elements. Only by amphoteric metal elements. We know the amphoteric nature. It has the ability to react with both acids and base. Only amphoteric metal ions initially give a precipitate with limited amount of OH minus. With the excess, those precipitate are dissolved. Give me an example for an amphoteric metal element. Example is aluminium 3 plus. Guys, aluminium 3 plus AQ is aluminium hydroxide with limited amount of OH minus, which is a white color precipitate. With the excess OH minus, it is dissolved and converted to AlOH4 माइनस अभी नोट डाउन करेगी नहीं मिला भाई अरे नोट डाउन करेगी नहीं मो लिया अंडरलाइन करना बल नोट गिला amphoteric hydroxide is if a certain hydroxide precipitate dissolve in both strong acid and strong bases it is known as an amphoteric hydroxide underline करना वदेगात मधे अरे beryllium aluminium tin lead zinc and chromium gives amphoteric hydroxides Harry, amphoteric hydroxides. Harry. Note take a guy to give me lamai. Note take a key of the Harry. I will attempt to put the inform Megadalaliagamu, page number 16, anywhere, Koyari Prashna and Namata. Leon Bhima. Amphoteric metal ions. Amphoteric metal ions. Initially give a precipitate with amphoteric metal ions give a precipitate with limited amount of OH minus limited amount of OH minus but that hydroxide dissolve in the presence of excess OH minus in the presence of excess OH minus. Hare. Lamai note के तीनों reaction टिकाक हरी तनिन तरह दीला अभी हम करें मधु page number 16 में पहाड़ में हरी उसमें से के reaction टिकाक तीनों नहीं एक लोगों ने हितान में आने पर neglect करेगा वो हरी हम fully में भी reaction टिकल याना हरी वालत नाते कल याद आना हरी Zinc 2 plus AQ, it is a amphoteric metal with OH minus. Initially it goes to Zn OH2 solid, which is a white color precipitate. In the presence of excess OH minus, guys, it is also dissolved and convert to Zn OH4 2 minus AQ. Here 2 minus, the thing happened. Initially it gives a white precipitate. With excess OH minus, the precipitate dissolve. There are few more metal ions. Pb2 plus is there. With OH minus, initially white precipitate lead hydroxide is given. It is a white precipitate. With excess OH minus, it goes to PbOH4 2 minus AQ. PbOH4 2 minus AQ. All these things are colorless. Here colorless AQ, here colorless AQ, here also colorless AQ. Okay. Sn2 plus initially with OH minus it gives SnOH twice solid. It dissolves in the presence of excess OH minus and convert to SnOH4 2 minus colorless. Here white precipitate, here colorless solution. So if they ask you a question, which kind of metal cations initially give a precipitate with limited amount of base and excess amount it dissolve, your answer is amphoteric metal ions. Aluminium 3 plus, zinc 2 plus, lead 2 plus, tin 2 plus. There is a very important reaction because all these amphoteric metal ions, white precipitates and colorless solutions, but except one, chromium 3 plus guys, sorry, chromium 3 plus with OH minus, it convert to Cr OH thrice solid. With excess OH minus, it convert to Cr OH 6 3 minus. Here, this one is a green color precipitate, chromium hydroxide green color precipitate, and CrOH 6 3 minus is a green color aqueous solution. Really important thing. When we add in sodium hydroxide, a green precipitate obtained, and with the further addition of OH minus, a green color solution obtained. That is by chromium. That is by chromium. So, could you write down all these reactions? Page number 16 වල අන්තිමටම තියෙන ස්පේස් එකේ ඒ ඉක්වේෂන් මොනවත් හිතන්නේ නැතුව මේ ටික ලියමු ළමයි. හරි. quickly on ළමයි මම අද flow charts ගාවට එනකම් විතරක් ඉවර කරනවා. හරි. ඒ කියන්නේ අපි අර ටාගට් කරපු ටයිම් එකට වඩා චුට්ටක් කලින් ඉවර වෙයි එහෙමනොත්. හරි. අපි බලමු මොකක්ද වෙන්නේ කියලා. හරි. බය වෙන්න එපා. මේ මාසය ඇතුලේ ඉන්න ඔක්කොටම මම ඉනෝගනික් පුළුවන් කරලා දෙනවා. ඒක ප්‍රොමිස් එකක්. හරි. ඒ කියන්නේ ටියුට් එක කම්ප්ලීට් කරන එක, පාස් පේපර් ක්වෙස්චන්ස් වලට ආන්සර් ලියවලා දෙන එක ඔක්කොම වැඩේ කොට දාලා දෙනවා. හරි. මොකද මේ ෂොට්ටක් කලින් නතර කරන්න හේතුව මේ හෙට ට්‍රිප් එක යන එකේ ඩ්‍රයිව් කරන එකත් මටම කරන්න ලා තියෙනවා. හරි. ඒක හින්දා හරි. ටාර්ගට් ලියමු. හරි. when we add OH minus හරි to amphoteric metal ions, initially they gave a precipitate. Majority of amphoteric metal hydroxides are white in color except chromium, that is green. Hurry. With the further addition hurry, of OH minus, those precipitates are dissolved. Hurry. Majority are colorless solutions except chromium, that is a green color aqueous one. Okay. Hurry. Inorganic section එකේ ලකුණු 24 ගන්න එක, organic section එකේ 24 තියෙනවා ඒක ගන්න එක මහා දේවල් නෙවෙයි ළමයි. හරි. ගේම තියෙන ෆිසිකල් වල ඒක 25 අය දන්නවා. හරි. ෆිසිකල් වල දඩ ගේමක් තියෙනවා, especially when you go to the 30th unit. For the 30th unit I told you there are 30 marks. අන්න ගේම තියෙන තැන. හරි. හරි. that is okay. අපි මේ ළඟ එකට හරි. Guys, now if I ask you, when a base is added, initially a precipitate is given. With the further addition of the base, precipitate dissolve. You guys know those things are amphoteric metal ions. These are the examples. Okay. Can I remove this one? Sorry? Can I remove this one? Only amphoteric metal ions. Give that one. Hurry. Okay. I'm going to remove only the above reaction, about two reactions. Hurry. May two reactions man remove karna. Now, like that, when we add in aqueous ammonia, that is equal to ammonium hydroxide. Hurry, same thing. initially a precipitate obtained. Initially precipitate obtained with the further addition of ammonia AQ, this precipitate dissolve. This is given by D7, D8, D9, D10 configurations. When we add in sodium hydroxide, initially a precipitate obtained. That precipitate dissolved with the further addition of base, that is with the amphoteric metal ions, aluminium, zinc, beryllium, tin, lead, like that. When we add in ammonia, initially a precipitate obtained. With the further addition, if the precipitate dissolve, the metal cation definitely be D7, D8, D9, D10 configuration, which means cobalt, nickel, copper, zinc. Cobalt, nickel, copper, zinc. Point form එකක් තියාගමු ඊළඟ page එක 9 page එකේ. හරි. When aqueous fill කරමුකෝ, ammonia is added. When aqueous ammonia is added, page number 17 ළමයි. Page number 17. When aqueous ammonia is added, it precipitate as OH minus. And when excess ammonia is added, remove කරමුද වචන ටිකක්. Then it form OH minus which dissolve in aqueous කියන එක අයින් කරන්නකො. ඔය අන්තිම වාක්‍යය අයින් කරන්නකො එතන. Then it forms OH minus when dissolve in aqueous කියන එක අයින් කරන්න. Totally අයින් කරන්න. Okay. Totally අයින් කරන්න එතන. ඒක totally අයින් කරමු. හරි. ළමයි when excess ammonia is added, the precipitate dissolve. වාක්‍ය හදාගමු. When excess ammonia is added, the precipitate is dissolved in D7, ඉවර පාන කිලියක් කවන්නේ, D7, D8, D9, D10 configurations. D7, D8, D9, D10 configurations. Hurry. D7, D8, D9, D10 configurations. Okay. චුට්ටක් බලාගෙන ඉන්න. මේකේ රිමූව් කරන්න ඕන ටිකකුත් තියෙනවා. ඒ ටික අපි රිමූව් කරමු පස්සේ. මම ලියන එක බලාගෙන ඉන්න. ළමයි when we add in cobalt 2 plus, when we add in ammonia AQ solution to cobalt 2 plus, initially cobalt hydroxide is producing. Guys, cobalt 2 plus is a pink color AQ. Cobalt hydroxide is a pink color precipitate. Hari? Confusion nepa kohomada OH minus aavu kiyala. Abhi under the flow chart, we are write down all these reactions again. Hari? So no need to worry. Hari? Pink precipitate obtained. This precipitate dissolved in excess and it form cobalt ammonia 6 2 plus. It is AQ. When you come to cobalt ammonia 6 2 plus, that is yellowish brown. It is yellowish brown. yellowish brown. හරි. nickel hydroxide ළමයි, it is a green color precipitate with ammonia. Sorry. Nickel 2 plus AQ is a green color solution. When we add limited ammonia, nickel hydroxide is obtained, which is a green color precipitate. With excess ammonia, it goes to deep blue complex. The complex is Ni, NH3, 6, 2 plus AQ. Here it is deep blue AQ. And 29th one, copper 2 plus AQ. It is a pale blue solution. This is a pale blue solution. In the presence of limited ammonia, it goes to copper hydroxide, which is a blue color precipitate, PBT. In the presence of excess ammonia, it converts to copper ammonia, that is not 6, it is 4, 2 plus. Again the color is deep blue. Again the color is deep blue. The last example, zinc 2 plus AQ. It is colorless lamai. It is colorless. In the presence of limited ammonia, it goes to zinc hydroxide solid, which is a white color precipitate. White color precipitate. With the excess ammonia, it goes to zinc ammonia 4 2 plus. These are the examples. That is also colorless. ළමයි එහෙනම් chromium ගේ කෝණේ නෑ ඒක remove කරන්න. chromium ගේ කෝණේ නෑ ඒක remove කරන්න. cobalt 3 plus නෙමෙයි change කරන්න to cobalt 2 plus. nickel 2 plus is okay. Copper 2 plus is okay. Remove zinc plus totally. Zinc 2 plus is the only 4 reactions are okay. Only 4 reactions are there. Can you fill these 4 reactions? Look at this one. When we add in limited amount of ammonia, initially precipitate obtained. Then with the excess ammonia, those precipitate are dissolved. That is given by D7 to D10 configurations only. If they ask you, when adding, actually within this point, essay question එකක්ම හදන්න පුළුවන්. කොහොමද හදන්නේ? When adding limited ammonia to a green color aqueous solution, a green color precipitate is given. With the excess ammonia, it converts to deep blue color solution. What is the metal ion? What is the charge on it? What is the electronic configuration of that one? එන්න තමයි question එක අහන්නේ. හරි. So probably මේක දැනගෙන තියෙන්න ඕනේ. හරි. Quickly ලියමු. Now you know the 2 famous points I gave you now after the break. When we add in sodium hydroxide initially a precipitate given. With the further addition, if the precipitate dissolve, that is definitely need to be a amphoteric metal element. When we add in ammonia initially, a precipitate is formed, and with the excess ammonia, if the precipitate dissolve, that definitely need to be D7 to D9 configurations. Quickly ලියමු එහෙනම්. හරි. තාම අපි කැටායන් හරියට ගියේ නෑ ළමයි. හරි. දැන් තියෙන ගෑසස් ටික සෙපරේට් කරගන්න විදිය. හරි. ඒ ටිකත් ඔක්කොම ඉවර කරගෙන තමයි page number 22 වලදී තමයි කැටායන් start කරන්න තියෙන්නේ. quickly මේ ටික ලියා ගන්න, fill කරගන්න. quickly ලියාගමු මේ ටික. හරි. කෙමිස්ට්‍රි කියන සබ්ජෙක්ට් එක ළමයි අමාරු හරි. ඔය හරි දේවල් හරි විදිහට පාඩම් කරොත් වැඩේ කර දා ගන්න පුළුවන්. හරි. අපි යමුද ඉස්සරහට මම රිමූව් කරන්නද මේක? මොකද කියන්නේ? Okay guys, I'm going to remove this one. Hurry. I'm going to remove this one. Hurry. Okay. I'm removing only the first two reactions here. Okay. Guys, look at this one. Hurry. Lamai, aqueous ammonia is formula එක වැරදිලානේ. That is not NH3OH. That is NH4OH. Aqueous ammonia is NH4OH formed by dissolving ammonia in water. Ammonium hydroxide, then again NH4OH. It is a weak base. Are you okay with that one? Hurry. Okay. Guys, now let's go to identify gases. Hurry. These are very important things. Hurry. I'm going to remove these things. Okay. Guys, how you can identify carbon dioxide? Previously I mentioned that. How you can identify carbon dioxide? Lamai, actually, here, to identify carbon dioxide, initially we are passing carbon dioxide gas through calcium hydroxide solution, which is known as lime. Initially, a white precipitate obtained, which is calcium carbonate, and water is produced. If we further pass carbon dioxide gas through that result precipitate, the thing happen here is precipitate dissolve and an aqueous solution is formed. Calcium bicarbonate is formed. You know that one. Hurry. When we pass carbon dioxide through lime water, initially a white precipitate obtained. When we pass carbon dioxide more through that white precipitate, that precipitate dissolve. Remember, not only carbon dioxide, but also sulfur dioxide gas also giving the same observation. Okay? Not only carbon dioxide, sulfur dioxide also giving the same observation. Look at this one, the same things happen. When you pass sulfur dioxide gas through a solution of calcium hydroxide lamai, initially calcium sulfite solid, which is a white PPT precipitate. Here this one also white precipitate form with water. But if you pass further sulfur dioxide through that, produce calcium sulfite, which is white precipitate. Hurry. The precipitate dissolve and it convert to calcium bisulfite, which is a aqueous solution. Here colorless AQ, here also colorless AQ. These are the points we need to know. Without the, I know majority of you guys know the first point, but make a done percentage එක අඩුයිනේ. අන්න ඕන තැන. හරි. අපි යන් ඒක lime water test for carbon dioxide and sulfur dioxide. Look at the thing. Lime water is an aqueous solution of calcium hydroxide and it is colorless. Hurry. When carbon dioxide or sulfur dioxide gas are passed through colorless lime water, initially it turns milky color, a white precipitate, milky color. When excess carbon dioxide is passed through the milky solution, the milky color disappears. Similarly, when excess SO2 is passed through the milky solution, the milkiness also disappeared. Therefore, both carbon dioxide and sulfur dioxide give same observation with lime water. Underline karanna and write down the reactions. Initially, guys, they convert to the carbonate, then to bicarbonate. Here the same thing happened. Initially to the sulfite, then bisulfite. Okay. Both carbon dioxide and sulfur dioxide give white precipitate, but further with those gases, that milky color white precipitate dissolve and convert to a colorless solution. Okay, bye. Hari there. Hari. Let's go to page number 18. Page number 18. Hari. Page number 18. Page number 18. Test 4. Separately identify sulfur dioxide and H2S. Below, H2S gas is released when we add in dilute acid to sulfide, and sulfur dioxide gas is released when we add in dilute acid to SO3 2 minus. Okay, I told you H2S contain a rotten egg smell and sulfur dioxide contain a gunpowder smell. Hurry, guys, let's see. Lamai, initially we are trying to identify these two solutions by using Pb2 plus. Okay, Pb2 plus. Look at this one. Two separate test tubes are taken, each containing lead nitrate and or lead acetate. Then gases H2S and sulfur dioxide are passed separately through these solutions. Okay, guys, look at this one. Pb2 plus solutions are there. Hurry. If we pass H2S according to the theory, hurry, a black precipitate is produced. So definitely we know that is lead sulfide. This is the black precipitate and 2H pluses. Hurry. Here, when we pass sulfur dioxide through Pb2 plus, water need to be right down here. It converts to lead sulfide and 2H pluses. Here lead sulfide, it is a white color precipitate. Can you quickly write down these things? Hurry. And I will give you another important experiment here. Hurry. Lavai. Hurry. Guys, we have to use a filter paper. We have to dip that filter paper in lead nitrate or lead acetate solution, which means the filter paper contains Pb2 plus, no? If we expose H2S gas to the filter paper, actually you can obtain black dots on the filter paper. The same reaction take place. Hurry. Here also Pb2 plus react with H2S and given lead sulfide solid and 2H plus. This is the black precipitate. මම මේක ගැන note එක දෙන්නම්. reaction දෙක ඉස්සලා ලියාගෙන use that page ඔයාලට කැමති විදිහට use කරන්න. හරි. අවුලක් නැහැ. හරි. First two reactions only. Hurry. First two reactions only. Okay, let's write down about this experiment under page number 18 lamai. Under page number 18, let's write down about this experiment. Hurry. Apelimu. Hurry. Guys, හැමෝම touch එකේ ඉන්න. මම complete කරන්නේ. Hurry. Up to page number 21. හොඳයි. Up to page number 21. 21 complete කරමු අපි. හරි. ඉතුරු ටික තියෙන flow charts ටික. හරි. ඒකත් මම වෙනම දවසක් අරගෙන ඔයාලට කියලා දෙනවා. ඒකින්ද worry වෙන්න එපා. හරි questions කරන දවසේ අපි ඒක discuss කරමු. හරි. හැමෝම හැබැයි past papers පොතක් අරගෙන තියාගන්න. මොකද ඕනනේ දැන් ඔක ඉස්සරහට. හරි. හරි. ලියන්න එහෙම. හරි. Point form. When H2S gas is passed through, when H2S gas is passed through, when H2S gas is passed through a filter paper dipped in lead nitrate or lead acetate, black dots can be seen in the filter paper. Black dots can be seen in the filter paper. If you expose H2S gas to a filter paper which is dipped in Pb2 plus solution, you can obtain black dots here. So draw this diagram. Hurry. You can clearly see there are black dots in the filter paper. Hurry, this is the reaction. The same above reaction is there. Guys, I'm going to remove these upper reactions. Here, these reactions. Hurry. I'm going to remove these things. Hurry. Here also. And reaction as well. Hurry. Okay. ලොකුම important එකක් නෑනේ page number 19. Quickly අපි යමු ඒකට. Let's look at this one. Page number 19. Separately identification of H2S and sulfur dioxide by using silver nitrate and silver acetate solutions. Go to the theory. Two separate test tubes are taken, each containing silver nitrate or silver acetate. Ag plus is there. Then H2S and sulfur dioxide are passed separately. Underline karanna. If we pass H2S through silver nitrate or silver acetate, a black color Ag2S, silver sulfide, is obtained. Black color silver sulfide Ag2S is obtained. If we pass sulfur dioxide, white color Ag2SO3 is obtained. If you pass H2S through Ag plus black color precipitate, if you pass sulfur dioxide through Ag plus a white color precipitate obtain. Are you okay with that one? ඊළඟ passing H2S and sulfur dioxide through copper sulfate solutions. Underline karanna, if you pass H2S through copper sulfate, balana lamai, a black color copper sulfide precipitate obtain. Underline karanna, black color copper sulfide precipitate obtain, and you cannot obtain any observation in the SO2. Okay. Guys, D. Identification using colored flower petals. Guys, I told you sulfur dioxide contain bleaching property. So sulfur dioxide can decolorize wet surfaces, wet colored surfaces, but that is temporary. Underline karanna. Sulfur dioxide is a bleaching. Underline karanna ulla dee thamai the bleaching effect is temporarily. In the wet environments, ඒක හින්දා මත point form දාලා ලියන්න ඕන නම් හරි වෙන මොන්න හරි SO2 bleach wet surfaces only, wet surfaces only, and that is a temporary effect, and that is a temporary effect. If the surface dry again, then the original color reappear. Okay, so this is a temporary bleaching, but when you come to chlorine, that is a permanent bleaching. Chlorine එකක් දැම්ම මොකක් හරි ඇඳුමකට දැම්මොත් color එක permanently වයින් වෙනවනේ. හරි, but sulfur dioxide that is a temporary. හරි, okay. Page number 19 ලොකු දෙයක් නැත දේ එතනින් එහා. යමු ඉස්සරහට. හරි. යමු ඉස්සරහට. හරි. මෙන්න වැදගත් එකක් තමයි. Look at this one. E. Identification of gases using acidic KMnO4 or acidic dichromate. Okay, look at this one. Acidic KMnO4. Guys, H2S with sulfur dioxide with permanganate in acidic medium. What are the products? Now you have the ability to write down the reaction by identifying the proper products. Permanganate in acidic medium, I told you, it convert to Mn2 plus. Previously, we had H2S, I told you, H2S convert to sulfur. Sulfur dioxide, permanganate reduce, sulfur dioxide oxidized to sulfate. Could you quickly balance these equations? I will give the observations properly. Can you quickly write down these equations? Under permanganate case, hurry, identification using acidified KMnO4. To the right, there is a space. In that space, quickly write down the equations and write down the observation you can get from these equations and how you can separately identify whether it is H2S or sulfur dioxide. Quickly write down. Quickly write down. Sorry. Equally on. Okay. In the first case, you can clearly see H2S, here sulfur -2, here sulfur 0. Even I don't use arrow right now. We don't need those things. Hurry. Permanganate manganese +7, here +2. 7 to 2 gap, what is the gap here? 5. -2 to 0 gap, what is the gap here? That is 2. Here gap 5, you have to multiply by 2. Here gap 2, you have to multiply by 5. 5H2S, 5 sulfur, 2Mn2 plus 2 permanganate in acidic medium. So you have to add H plus and water. You can clearly see it contains only 8 oxygen, which means 8 water, 16 H pluses, total 10 here, 6 H pluses you have to add. If you balance this equation, here plus 4, here plus 6, here plus 2, here plus 7, plus 7 to plus 2, the gap 5, here gap 2. 2 you have to multiply by 5 again. 5 dioxide, 5 sulfate, 2Mn2 plus 2 permanganate. Total oxygen 20 here, here 10, here 8, 18. You have to add 2 water molecules to here, which means 4H pluses to the other side. Okay, so 4H pluses to the other side. I told you permanganate, it is purple in color. Sorry, here also purple. When you come to Mn2 plus, that is really pale pink. For our naked eye, that is colorless. Here colorless. Here colorless. So my question is, can you identify, can you separate H2S and sulfur dioxide by using acidified KMnO4, acidified permanganate? Can you separate these two? Yes, exactly. Why? Here, purple color solution turned to colorless solution with turbidity because sulfur is there. I told you sulfur is a suspension. But when you come to the second reaction, guys, you can clearly see it is, there are no sulfur. So in this second case, the purple color solution convert to clear colorless solution. In the first case, it is a colorless solution but with the turbidity. So quickly write down this one and write down the difference between these two. You can separate sulfur dioxide and H2S using acidified permanganate. Okay. Then in the section B, I gave you the reaction oddly unknown H2S and sulfur dioxide with dichromate. Could you quickly write down the reactions and quickly give the observations? Sorry, along in the page එකක් විතර වගේ complete කරන්න තියෙන්නේ. හරි, close to 2 pm වගේ වෙද්දී හරි මේක ඉවර කරන්න පුළුවන් වෙයි. ඒකෙත් අපි ammonia identify කරගත්තානේ නේ. ඒකින්ද quickly වැඩේකට දාන්න පුළුවන්. හරි, අල්ලන් ඉන්න. හරි, ඉතින් අපි අද දවසේ 21 page වලට නිකන් විතරයි අපිට cover කරන්න වෙන්නේ. හරි, okay, quickly balance කරලා දෙන්න මට. Quickly balance the equations and write down your observations and how you are separating these two gases by using dichromate. Hurry. First one is clear, no? Hurry. Purple to colorless with turbidity. That is H2S. In the second one, purple to colorless clean solution. Okay. Identify this one also. How can I identify H2S and sulfur dioxide using dichromates? Okay. Okay, guys, I told you sulfur H2S, it goes to sulfur and chromium convert to Cr3 plus. Here dichromate again convert to Cr3 plus, but sulfur dioxide convert to SO4 2 minus. Okay, now you have to balance. How you can balance this one? How you can balance this one? Hurry. Let me look at this one. When you come to H2S, minus 2. Ne? Sulfur, oxidation state 0. Dichromate, plus 6 into 2. 2 chromium you have to consider. Here, plus 3 into 2, plus 6. 12 to 6, gap 6. 2 to 0, gap 0. Sorry, 2 to 0, gap 2. Previous gap 6. So, gap 2 you have to multiply by 3. 3H2S, 3 sulfur, dichromate, 2Cr3 plus, 7H2O, 14H pluses, but here 6, so 8H pluses. So what is the color change? Here, dichromate, the color is orange. It is orange. Cr3 plus, in acidic medium, it is a green color solution. But sulfur is there. So how you can write down the observation? Orange color convert to green color with turbidity. Green color with turbidity. Are you okay with that one? Green color with turbidity. And when you come to the last reaction here, dichromate with sulfur dioxide, again sulfur dioxide plus 4. Actually no need to represent these arrows. Time consuming, time wasting. Here it is plus 6. Plus 6. So here when you come to dichromate, plus 6 into 2. Here you have to consider 2. So plus 3 into 2. So here 4 to 6 gap, that is 2. And 12 to 6 gap, that is 6. Are you okay with that one? So gap here 6, here 2. So 2 you have to multiply by 3. Here 3, here 3, here 1, here 2. Total 13 oxygen, 3 into 2, 6. Here 7, 13, here 12. So 1 water molecule and 2H pluses. 2H pluses. Okay. So what is the observation here? Again orange lamai, and here Cr3 plus green and clear green solution. So the difference between when you add in sulfur dioxide and H2S separately to dichromate, the color of dichromate turns from orange to green. That is okay. But if you use H2S, you can obtain a green color solution with a turbidity. If you use sulfur dioxide, you can obtain a clear green color solution. Clear green color solution. Are you okay? So using dichromate also, you can separate H2S and sulfur dioxide. එහෙනම් අද දවසේ අන්තිම page එක. හරි? Extremely sorry. අර කියපු time එකට එනකන් අපිට කරන්න බැරි වෙන එකට. හරි? හිතුවේ නැති සිටුේෂන් එකක් වෙලා තියෙන්නේ. මොකද ට්‍රිප් එකේ වාහනේ ඩ්‍රයිව් කරන්න හිටියේ මම නෙමෙයි. හරි. ඒක ඩ්‍රයිව් කරන්න වෙනවා. හරි. ඩ්‍රයිව් කරන්න හිටපු උන් ඩ්‍රයිව් කරන්න බැරි තත්ත්වයක් තියෙන්නේ. හරි. වැඩක් නැහැ ඉතින් කතා කරලා. හරි. මම ඩ්‍රයිව් කරනවා. වෙන මොනවා කරන්නද? හරි. Are you okay with this one? Hurry. Hurry. Clear the hurry. Antim ekata yanga. Hurry. Guys, it is really important thing. When you come to cations, always godak ay hitanne only about the metal cations. But except the metal cations, NH4 plus is there, ammonium. Hurry. Make a hurry with questions already go down. Hurry, guys, can I remove these things? Hurry. I'm going to remove all these things now. I'm going to remove all these things. Okay. Lamai, situations where ammonia gas is released. Really important section. Very important section. Today I told you nitrate ions and nitrite ions release ammonia in the presence of aluminium powder or zinc powder in basic medium. They release ammonia. We discussed this one under the Nestle, under the aluminium Devada experiment. Hari. First take ammonia gas is released in the presence of product වැරදිලා නේද note එක පොඩක් එහෙට මෙහෙට ගිහිල්ලා අකුරු ටික හදාගන්න NO2 minus and NO3 minus during Devada's alloy test. When aluminium powder or zinc powder is used in alkaline medium, then එතරම් හදන්න වෙනවා NO2 minus and NO3 minus react to release ammonia. No need to balance the equation again and again. We already balanced no. Again අපි මෙතන එතන මේ වගේ ලියාගමු. හරි මේ වගේ ලියාගන්න. හරි. There are 4 cases release of ammonia. This is the first case. Nitrate and nitrite with aluminium zinc powder with alkaline medium. Alkaline mean basic medium. Hari? So we already balanced this one. Second experiment, second type of the reaction. This is a very important reaction. Guys, look at this one. When we add in a strong base to any ammonium salt, strong base to any ammonium salt, ammonia gas is released. Very important point. Hari. So assume ammonium chloride, Hari, solid or AQ anything. If it is ammonium carbonate, Hari, it can be solid or AQ, Hari. Ammonium sulfate, solid or AQ, Hari. Here in all these cases ammonia gas release. Hari. So මම එක point කරලා දෙනවා එම්ලියමු එක. Under the second point right hand side එක equation ටික ලියන්න space එක තියාගමු ළමයි. ඒද okay. හරි. පොඩක් අර ammonium plus OH minus ammonia කියලා තියෙනවානේ. ඒක පහලින් ලියන්න මෙහෙම. Any ammonium salt release ammonia gas release ammonia gas release ammonia gas release ammonia gas release ammonia when strong base is added. When strong base is added, could you write down those equations? When strong base is added, Hari, strong base is added, Hari. Antima chutta alangina වැඩි ඉවරයි වගේ. හරි චුට්ටයි තියෙන තව. හරි. Write down these 3 reactions. Write down those 3 reactions. Guys, I told you that adding any nitrite to water will give ammonia gas. Do you remember? I write down when adding magnesium nitride to water, it produces magnesium hydroxide, which is a white gelatinous precipitate, and ammonia. Hari. So, ilangike e katawa kiyanne. Hari, ammonia gas is released when water is added to any metal nitride. I told you about lithium nitride, magnesium nitride, so don't need to write down again and again. Hari, okay? මෙන්න fourth එක බුදු අම්මෝ ගණන් වල එන්න තියෙන KSම equation එකක්. KSම equation එකක් ගණන් වල එන්න තියෙන chemical calculations වල ළමයි Menu counter calculations, redox titrations, usually fertilizer questions, they are really hard. Because those questions, they can be connected to pH. Methyl orange phenolphthalein titrations. හරි එකින් දැන් මෙතන කේස් එකක් තියෙන රියැක්ෂන් එකක්. අපි දැන් ගණන් හදන්නේ නේ. This chemical compound CONH2 twice. කවුද මේ? දන්නවද? This is known as urea. This is known as urea. When you add in sodium hydroxide to urea, okay, it is not balanced. Balance කරලා දාන්න ළමයි. It produces sodium carbonate plus ammonia. Sodium carbonate plus ammonia. Okay, this is the reaction. When we add in sodium hydroxide to urea, sodium carbonate and ammonia is producing. For fertilizer titrations, we are using this one. එක හදන්න තරම් තාම වාට දැනුමක් නැත. හරි. ඒක balance nowadays, I think 2 ammonia. There is 2 ammonia. Then it is balance. Hurry. So, in all these cases, ammonia gas evolving. So, we are having few methods to identify ammonia. You know those things now. Using the litmus papers, we can identify that one. Ammonia is the only basic gas in A-level syllabus. It turns red litmus to blue. That is the first case. In the second case, we can use a reagent called Nestle. It turns the color to brown. And you can use a glass rod which contains HCl moist. If you expose to ammonia gas, it will give ammonium chloride, which is a thick white smoke. Are you okay with that one? Hari. Hari. මං හිතන්නේ time is close to 2 PM. හරි ළමයි අද මම මෙතනින් අපේ ටියුට් එක නතර කරනවා. හරි එහෙනම් හැමෝම මේ ටික පාඩම් කරන්න, note down කරගන්න, flow charts ටික discuss කරාට පස්සේ හරි organic ප්‍රශ්න කරගෙන A-level pass paper question අස්සන්ට මතක් වෙයි. මම මේ දීපු දේවල් ටිකම නේද තියෙන්නේ. මේක ඇතුලේ අර group 14 පාඩම් කරන්න ඕනේ, 16 පාඩම් 7 එහෙම දෙයක් නෙමෙයි තියෙන්නේ. ඔයාලට තේරෙයි තව පොඩි වෙලාවක් ඇතුළත මොකද්ද මේකේ කතන්දරේ කියලා. එහෙනම් හැමෝටම හරි good night. අද ක්ලාස් එක මම මෙතනින් නතර කරනවා. මම trip එක ගිහිල්ලා ඇවිල්ලා හරි ආය link එකක් දානවා. ඒ link එකේදී flow charts එක complete කරගෙන අපි past paper questions කරන්න පටන් ගමු. target එක තියෙන්නේ මේ මාසය ඇතුළත inorganic complete කරලා දෙන එක ඔයාලට. එහෙනම් හැමෝටම good night, tata bye. හරි මහන්සි වෙන වැඩ කරන්න.